All right. I think I'm up. Let's see, am I up? Yeah, okay, cool. All right. Today, we're going to do more tiny Webdev LLM stuff. So, last time, let's not open that up. So, last time, I was getting the data set. And I'll go back to what the data set is. Let me go to the README. So we were fine tuning our model, which consists of prompts like these. Okay, so it has the title of the web page, and then this compressed version of the HTML, which I can go over real quick, that I have where, before I even do that, let me talk about my mission. Okay, so I have this mission to never code again. I'm sick of the web dev work. I'm sick of all the BS. I just want to get to a point where I can just tell my computer, hey, code for me. The problem is, I want to be able to design websites almost like how a web dev works and just run it on my CPU very quickly. What I mean by that is GPT-4, even Llama, all these models, they're trained on so much, even StarCoder, they're trained on so much data. But it doesn't have a lot of intention behind it in terms of training it to solve a user problem. So my thought is, let's actually try to train a model to be as small as we can, to get the data set as condensed as we can, and cater the data set of our code, our HTML and CSS code, so that it's perfect for a transformer to gain knowledge on. So what I mean by that is, so first we embed the styles in the HTML. So let me see if I can get a data set right here. This is like 14 megabytes. This is way too much. So like, oh my god. Anyway, so you see how this, you probably can't see, but I have a script where for every single element, I go through each element, and then I get the computed styles on the element. I do a diffing thing so I don't get all the default styles, if you know what I mean. And then I add that to the element, and then at each and every element on the page, and you can actually see what it looks like here. I don't know why I should have clicked that one. So this is a long site, and it's compressed. But really what this is a super long series of HTML elements where the total design CSS of the page is embedded in the HTML, and there's no scripts, there's nothing, it's just a static site. So we're really making an intelligent static site generator. And we're going to train this, tokenize this, and train this on a GPT model. I'm going to try a few. I've been doing Llama so far, but I actually want to try it out on a really small model first and just see how good we can get it on our data set. And then we'll see. But I'm only going to do that after one part, and that is I want to make, and I've had this idea for a bit, and I messed it up the first time like a month ago. But now that I'm streaming, and I'm trying to really push myself here. We may not do this, but I want to make a semantic CSS framework. So what is a semantic CSS framework? And we'll get into the coding in a bit, but I gotta show you what's going on here, so you guys see. What is it? So my idea is we don't have to train our transformers on the bigger and bigger models, or our LLM, casual LLM models on bigger and bigger data. We can actually try to get our data sets small and condensed, and we can try to figure things out in a way where we no longer have to get like, what is it, these 175 billion parameter models and all this, and we can actually cater these programming languages that we're trying to generalize from to be more contextual. So what I mean by that is, instead of having, so we'll have the body, and we'll have a div. So what I did, and okay, let's say we have like a h1 tag. Now, I'm working on this idea for a bit. I had this idea to take pictures of the websites and do some stable diffusion, and then convert the images to code, essentially. So how I want this to work is, I want to be able to ask a question that's like, design me a login page that looks like Facebook. And GPT-4 and things like that, they can often do things like this, right? So that's a challenge that well, actually, something like this, not so much. Sorry, one sec. I just need to quickly open up chat. But so they can largely do things like this, but a lot of what can't be done is being able to, one, do this in a compressed fashion. So not having to train the model with like the entire internet in order to figure out these type of semantics. That's one thing. So more of an efficiency problem. But two, the semantics and the stylistic approach to how people actually code. So when they say looks like Facebook, what does that really mean? So I want to generate a CSS framework, build a CSS framework, and I'm going to do it by web scraping and doing some clustering, and we'll get it in some topic modeling, and we'll get into that. But I want to design a CSS framework, generate it, that can do something like this. So right now, let's say we have, it's like, this is a website, whatever. We have a list, whatever. This is a meta website or whatever. That doesn't really matter. But the way I have this working now is, I actually, and let's say I have a list here, item 1, item 2. So the way I have it working now is, I actually make it so each item in the list has all the styles that it needs. So like, I don't know, like font size, whatever the default styles are, and then it has, cursor, pointer, or whatever. Like, and let's assume that this got, because I have a different thing to get rid of default styles, that I got rid of all the default styles and all that. So I do this for every single element, right? So I want to do something, and this is like ... So I want to do something where for all the websites I'm scraping on my data set, I group a lot of the websites together based on their similarity of content. That's where the semantics come from. So this is a meta website. Let's say I scrape 100 websites. A ton of them have similar topics that are meta. I will then find common groupings of these styles within that cluster. Let's say there's like 10 clusters. And I'll label that class with that cluster name, with that topic name. And then with that topic name, I'm going to create a CSS class, and then make a semantic.css file. So pretty much what we're going to do in the end is create a topic-based CSS framework trained because we're going to be doing some clustering with some dense word vectors. So trained off of a lot of websites. So in the end, we'll have something that's like, I don't know, meta dash, and it'll probably be like some random series of strings, and then this will be some common class. So maybe there's a common CSS grouping. So really, we're making a common.css. That's a good way of putting it. we're making a common.css. That makes sense to anyone. So cool. So now let's get started. There's a few things happening here. So actually, and I also need to like walk through the idea a little bit. So this is gonna take a sec. So like I want to group this up in a way where I want it to be grouped in a way where I can draw on the site, and I can get like the topics. Oh, I'm gonna draw. I like getting mixed up. So like I can get topics for each HTML page, and then do a sort of clustering, which I'm gonna use top to vec, which we'll run through in a sec. But I gotta figure out how this works, and I gotta sort of map this out. So before I do any project, I map it out. If you don't map things out, you're not cool. What's this site? I've been using like this sketch site. I think it kind of sucks though, but it's fine. I'm getting rid of this in like a second, so it doesn't really matter. I just like this. I just like drawing stuff out. So, oh yeah, this is a video from yesterday. Do they have the same video? Or do they have the same thing? That was on how to get freelance jobs. Alright, so first things first, we need to do the first thing first, I need to clean the scraper. But the way this is going to work, the first thing that happens is we already have a data set of scraped websites that we're going to use, by the way. But the first thing we're going to do is we're going to cluster our HTML websites based on content. Save topics. So we're gonna use top to vec it's the first thing we're doing. So we're gonna use top to vec to cluster. It's the first thing. And I'll run through how top to vec works and all that. So it's the first thing that's happening, and then this is gonna get to something where after we do that, we're gonna have to, let's say here, so we're gonna have to, I have such scribblings whenever I work. I scribble like a child. So we're gonna have to run the CSS framework generator on each cluster using the topics as prefixes. The topics is the semantic part, just by the way. But we're going to use the topics as prefixes in the CSS. And this is like a first pass, probably not the best way to do it, but we'll figure it out. So that's the semantics part. This is the semantics. This is like the meat of it, right? So we're getting semantic information. So we're getting this information on let's move all this up. So we're getting this semantic information first, and that's so funny. Oh, okay, cool. So we're getting this semantic information first, and then after we get the semantic info, we're gonna get some info related to the actual common CSS like arrays, like style combinations that are used on each style, which will make a script for that. And then we're going to save that into like different files, and then we're going to have to find a way to make a common, so let's actually go up here. So we're going to, using all that, generate a common CSS framework combining all the, and when I say, so by the way, if anyone's confused, when I say CSS framework, I mean like Bootstrap. It's just a series of CSS classes. That's when people say framework. It's not like a framework in the sense that we have like a Django framework where it's like an API with functionality. Typically when people say CSS framework, they really just mean like a bunch of classes, CSS classes, right? So combining all the frameworks, and we're gonna have to clean it up. So we deduplicate some of them. We do duplicate them into greater topics. So I'll get into that later, but we have to make sure that if we group a cluster and we name it whatever, like this is the news cluster or whatever, and we have some news dash CSS classes for that, we're gonna have to sort of combine all of these. So you have news dash, like if there's the same exact CSS class in another topic. I know this is all, I haven't coded any of this, so a lot of this is probably like kind of weird, but like this will make more sense as the video goes along. But we're gonna be combining these so that we just keep joining duplicate things into greater topics. And the cool thing about that is once we tokenize the CSS and the code, so that the code looks like, by the way, in the end, the code won't look like this. The code that we're gonna pass to the transformer is gonna look like class equals, news dash 123 meta dash 321. I don't know. Like maybe there's a history topic, or there's like a Wikipedia article topic. I don't know. By the way, this won't be a good CSS framework. This is not, I want to be very clear here. This is not a good CSS framework for development. This is for training a transformer model specifically. Okay? Like this isn't actually going to be like a good. Be very clear about that. Does that make sense? I feel like, I know like I've been so in the weeds thinking about how to do this for so long, that like now I'm like, it's actually kind of hilarious. Yeah. No, but alright, so design me so let me go back here. Alright, so let's do it. And these are I'm just going to give each one of these like tags. Like random class names. Alright, so hopefully that was clear. I just want to make sure everything's clear, because like it's funny when you're going in the weeds about a lot of things and you just like don't know how to translate it to the real world. I've had that so many times where it's like I've been working on ideas and I'm like, how do I actually translate this to the real world? Okay, cool. So let's go and do some of this. Oh, in the end, so after we do all this, this is a given, but we're gonna have to convert convert our data set to semantic CSS. And when we do inference and we generate our code, we're gonna wanna, when we try to get this to work, we're gonna have to get this semantic CSS file. Hopefully it's not too big. Hopefully it's not like more than a megabyte, right? That might be a problem, but for real. Okay, first things first. What's the first thing I actually want to like build though? Oh yeah, first things first, I actually want to clean the data set that we had. Yeah, that's the first thing I want to do. Actually, let me get it going. I have a, by the way, if anyone wants to, I know. If anyone wants to mess around with this code base, I have it on GitHub. So I generated a new one, if you've been following the other videos, that is more so a data set that has all the text of the page as metadata. So the way I'm getting the metadata, quote unquote, we're going to cluster with for each of these HTML pages is I'm just getting all the inner text on the page. I did that off video, I'm sorry. All right, so we have a data set that looks like the compressed HTML page with the embedded styles, and it's literally compressed, like I minify it and everything. Keep the closing tags, just to keep some more structure once it gets trained. By the way, I'm assuming this whole thing isn't to get the perfect Webdev model, it's to get a small one that can be effective, that we can maybe try to get close to effective as one of these actual LLMs for some specific tasks, like this task here of saying, where are we at? The task of saying, I have so many untitled things here. Like this task of saying, design me. I want to be able to do something like this eventually with enough data. And I want to be able to do this with like a super small model. We may even be able to just fine-tune GPT-2 for this. That's honestly my big, like if we could fine-tune something as small as GPT-2 for something like this, that would be incredible. We could even just mess around with Nano GPT and try that out. All right, cool. Let's do it. Let's get to it. Work it. It's not like I'm like telling people to squat. I'm like get to work. So I gotta clean the data set. So I just ran the web crawler to build a data set. This just goes through different websites and fetches does the style embeddings and then stores it, does the diffing for each style, for each element, and then stores it into a big JSON file. Understand I'm doing all this in Node mostly because I like scraping in Node. If you're not scraping in Node, I don't know what to tell you. Like I don't know what to tell you. Node's not perfect. Wait, actually, let me just use dashes this time. I feel like dashes is the way to go. Let's do async function. So we're gonna get into Python in a little bit though, because we have to do our clustering in Python. So we're gonna actually let's make a topic generator dot py. We're just gonna leave that there, and then we're gonna run through. First, let me clean the data set first and like actually look at it. But we'll do that in a sec. This is so big. So first, I'm gonna get the file system. We're gonna read I have this dataset.-0.json file. This is just an array of a ton of objects with the metadata and the HTML. So metadata, let's just call this dataset, my bad. And we're gonna wanna JSON parse. By the way, I did not do any energy drinks before this. This is all just power. This is just power level. All right, so let's just log dataset.length. Actually, you know what? Out of body armor. That is it's a little bit of an energy drink. Not really. It does not caffeinate. So let's run clean data. So I just want to see okay, so it has 14 things. That's it? Wow, that's crazy because it's like 26 megabytes. So we definitely need to compress this. By the way, this is also, we're trying to compress the data set too. We're trying to do two things. We're doing the Semantic CSS framework to compress the data set and to actually make it train better. Because just to go back to, I know I'm getting in the code and it's exciting, but let's get back to this real quick. this right here is not like this sequence this is going to be like 100 things in this style. These aren't contextual at all. It's not going to be learning. It doesn't have much to learn from cursor pointer in relation to font size 14. These are all independent things, which is fine. But I'm thinking if we convert this to a lot of things that are about what the page is about, we might be able to get some actually contextually relevant things, especially if the context window is smaller and we get to see it in relation to the tag name. And if you're wondering, I already went down the path of trying to do graph embeddings. I don't think it's worth it. So maybe for clustering HTML, if you want to make HTML embeddings, yeah, I've done that. And I think that's a good idea, but otherwise, I don't think it's that big of a deal. All right, so let's go and let's get into it. What do I mean by let's get into it? Okay. All right, yeah, let's go clean the data. So we're only using 14 websites right now, and it's 14 megabytes. So understand, this is definitely we're gonna have to compress the data. So if you want to clean your data sets, you have to think about the parameters. So I want to actually see how big each of these are. So I'm going to just tokenize it. So I'm just going to really just map each of these. So I'm going to map the length. I know the tokenizer is not going to be like that, but I think it's fine to just do spaces for now. I think this also deals with new line characters. So I think that should be fine. All right, so let's clean the data set. Why is it? Oh, these are, it's HTML. I think is what I call it. That's split. Is it not called HTML? What did I call it? I'm trying to look for the key because it's a key with the metadata. And the HTML, oh yeah, it is HTML. So what's going on there? So let's see what actually this is. It's actually log. This is an array. It said an array of 14. Now you have item, so it's actually log item. Instead, in our map, instead of returning just to see what's inside here. Oh wait, there's like an empty array in the end. It's so weird. What? So this is, let's see. That's fine. Oh, I saved the wrong buffers here. Or I saved the wrong data when I ran this. Pretty sure. Let me think. Yeah, I think I did. That's fine. But so it looks like in the end there's, oh no, this is just the result. This is what got logged. .html. Okay, so let's do .html.toString. Let's see if that works. I was supposed to save the actual string, but I did not. That's not true. There's no way it's a ton of twos. Let's do UTF-8. Okay, hold on. There's no way that's true. It says, oh no. Hold on a sec. So I use this. So what's happening is it's a buffer. This final HTML thing is a buffer from HTML. So I think when I load this, I have to do buffer. I have to load the buffer. Let me think. .data. .to. Oh, yeah, there's .data. Let's see if this works. Yep. Okay. Well, that's obviously not right, but getting closer. Oh no, you don't do UTF-8, I don't think. Yeah, no. Hold on a sec. Let's get rid of this. We don't need this. Convert buffer to string JS. Let's actually do this. Is that, I'm pretty sure, no, that's not it. So, toString, we think, buffer from toString. Let's see. I'm pretty sure the toString should have worked. And the default's UTF-8, so let's look at these items again. It's actually slice. Let's just get the first three when we're testing, because I don't want it to log a ton of stuff, because my computer is, I don't want my computer to freak out. Like, yeah, let's actually get rid of this live stream page. The computer is very sensitive. Okay, so oh, this is it. So it's .html dot buffer dot data dot HTML. So I think the toString should have worked. You know what? It's probably because I'm just trying to do this without having to run this again, but I think I might have to run it again. That's all right. You know what? I actually have another data set I can use, but it's not like structured as well, but it's fine. I'm going to have to use Cheerio to actually parse the data from that one, because the other one doesn't have the metadata, it just has the title data. Let me just see if I can, so load buffer data to string JavaScript. I just realized, do I care about this? Yeah, I do. To string Node.js. Yeah, I know that's how to do it, but clearly I'm doing something wrong. Something's not going right here. Convert stream buffers to UTF string. It's because I stored in this file, which should make sense. It should be serializable. Guess I can try without the dash. This is not 10x. Oh, my bad. .ht. .data. This is not 10. This is like this is 1x behavior. Oh, I think it's for the whole object. No? Let me see. JSON.stringify. It's so weird that it's stored like that, because the other file actually didn't store like that. Which is super weird. Let's do this. Oh wait, hold on. No, that's fine. Let me. I think it's because I stored it in a file. And the encoding's off in the file. Let me think. Let's see. Stored buffers, Node.js. Load from JSON file. Convert JSON object to buffer. Parse large. Okay. Let me see. Let's look at it, what it looks like again. I don't want to have to get the data set. Even the data set takes like 5 seconds to get. I can also. The weird thing is, I want to remove sites that are just too large, but I'm realizing this HTML field is the way I stored it this time is wrong. So this is modify buffer from, and then so how come when I loaded this file it actually was fine? Like if I load this file up into memory, it's big, but when I load the file up, it actually looks fine. Like it looks like raw characters. Yeah, okay, let me just close that. It's freaking out a little bit. So let's do okay, this doesn't matter too much. What I can do is I can use the other data set, this one. I can read this one. This one doesn't have metadata, but I need to get metadata from this, and I can use Cheerio for that. Oh, you know what? You know why it worked in the other one? Because I converted it. Oh, you know why the other one worked? Because I already converted it to a string, because I make it, I turn it into a prompt. So let me see if this works. If you concatenate the string. Because I've done that before now. .html. If I don't do toString. Oh, it's just it's like object. Let's do that. Let's see. Yeah, I just did the same thing. Okay, so buffer data Node.js load from file. We'll try to figure out how to load it in memory buffer file. Maybe this person's doing something similar. I have a feeling this person's doing something similar. Oh, you know what? Is that gonna do it? No. I don't know. Okay, so it reads the file. So you know what? Actually, what happens if I just read the file? And I just log the data set. I wonder if it actually has, because it's gonna be so big. Okay, alright, yeah, I get it. So it literally just has those numbers stored. Buffer. Okay, so buffer data to buffer object. So I want to load this buffer data into this buffer object. Random pickups just always happen all the time. It's just how it happens. Nothing's perfect. But we got to work it. Alright, so oh, you can actually allocate memory for that. Is that heap memory? Huh. That's interesting. Okay, so interesting. So you can, I might try to do this buffer from thing. So how do you import buffer? Oh, is it just a global? think it's just default UTF-8. Let's see. Okay, dataset map is not. Wait, what? Oh, my bad. I got rid of the JSON parse, and this doesn't do anything for us. It's a default anyway. This is how it is. This is how it is. Okay. Jesus. We did it. Alright. I was like, for a second, I was like a little, like, oh. Okay. So we had to get the raw data and put into a buffer string. Okay. So now we have the HTML string. And I just wanted to clean the data. Oh my god. Because this file's too big. It's like 26 gigs. So let's just return the length of this HTML string. Let's split it and then return the length. Let's get all the tokens, even though these aren't the real tokens. Okay, so this one's huge. Whatever this one is, no. Looks like in general, I'm just gonna take the ones. So this one's 51. I'll keep this one. I'll remove like these. So let's just like, let's do a filter, and then we'll return the length is less than 52,000. So all right, so that's actually it. That's all we want to do. I actually don't care about anything else when it comes to cleaning this for now. But yeah, we just want to write file sync. Notice how I use write file sync for a lot of things. When I use write file sync, what I'm doing is I'm doing a synchronous operation versus an async one because we're just writing a routine. I should just call it clean dataset. Data argument must be of type. Oh, my bad. So I have to stringify this JSON object before I store it into the file. I know I'm just doing a single file thing here. This isn't a very complicated script, cleaning script. Actually, let's not run this. Hold on. Let's just call it cleaned dataset. We're just removing stuff that's too big. Because when I'm testing, because we're just making a testing data set here. All right, so we have our clean data set. Let's make a script to now. Let's get into the. Now we want to get into the topic model. So let's go run over what we're going to use. So we're going to use, if you guys are unfamiliar, there's something called Word2Vec. I went over Word2Vec in another video. Word2Vec is very important. It's probably one of the most important like machine learning things you can do in our day and age. And I feel like, let me hold on one second. I'm just gonna let the chat know what's up. But yeah, so Word2Vec is really important. I'm gonna just describe real quick why it's important. And hold on a sec. I think there's something up. My stream's having some issues here. Okay, no, we're good. Sorry. Alright, so alright, we're back. Okay, so Word2Vec, what is Word2Vec? So just to go over what we're doing again before we go into Webdev. So what we're doing is we're making a semantic CSS framework so that when we could get our HTML data set for our tiny Webdev LLM, the transformer model can learn the context of each token to a higher degree. Instead of, so let's go to, let's go back to this explanation. So we have this embedded, so when we're training our model to answer questions like this, very similar to when you're asking ChatGPT 4 thing, but much smaller, we're going to be passing in a data set to train with this type of token prefix. We're going to have prefix tokens around this type of question. And the answer, after the answer token, we're going to be generating these tokens, which is going to be the website. And so that we keep the tokens close together, we're not going to generate all the HTML and then all the CSS. We're going to generate all the HTML with the style attribute and with all the styles embedded in each element, but which is cool and actually gives us better results. But the problem with that is each style, one, it's really long and there's nothing contextual about font size in comparison to cursor and font size in relation to H1 and the actual page that we're embedding. So we want to supercharge our data set with a semantic CSS framework so that our data set can look like this, and we can make all the classes have semantic information that's we're going to get from our topic modeling. So let's get into topic modeling. So I'm very new to Top2Vec, but I've been messing around with Word2Vec and Doc2Vec for a little bit. So let me get to an image a little bit. I'm picking up a lot of new things at once, so it's not an excuse, but you know, this is a good visual. So, well, is there a better? I steal my visuals. Actually, I'm gonna use both these visuals at the same time. Okay, so the way Word2Vec works is it gets vector representations for words by using this. Let's say you have some corpus of text. It uses context window, and here they have like a 5 context window to go through each word, and they're starting at 3 here, and it's getting the next 2 and the previous 2 tokens on each word here. So it's starting with the. Let me see. Oh wait, that didn't help at all. Just so you see here, so it's this one's starting with the, and then it's getting to quick, and then it's getting to brown, and it's learning what brown means based on the words it's in relation to. So part of the cool thing about that is where we get to understand how words work by looking at the words that it's in relation to. And the awesome thing about that is that we can build a framework on top of that. And what people have done is they've taken this idea and they've made something called Doc2Vec, and they've made something called Top2Vec, which is for topic modeling, which we're going to get into. And the really cool thing about this is you can do similarity searching, and you can do semantic searching, or similarity comparisons and semantic searching. So you can get a vector for a word that's king, and you can compare it to the word queen. You see, so imagine each of these vectors is a point in a scalar space. So just on an x and y graph. And king is close to queen. And it's close to man, but it's not as close to woman, right? You sort of understand that in this context window, moving is the thing that's learning these things more. So what we're going to do is to build our semantic CSS framework so we can just supercharge this tiny Webdev LLM with the smallest possible representation. We're going to be clustering each of the websites we get together so that we can do topics and figure out what the topic represents each of these web pages. So Top2Vec, the cool thing about Top2Vec that's getting me excited about this is this is something where we can actually we can start clustering our documents. Like imagine you like, here's a good business idea. Imagine you have some company that has years and years and years of data for their e-commerce business or whatever, or it's a law practice, and they have years and years and years of documents on these HTML pages, and they don't know how to search them, and they don't even know how to start searching them. They don't even know how to index them. They have like 10,000 different HTML pages. Using something like this, you could cluster all those pages and then use the words that are used to cluster them as labels and auto label their entire backlog of documents and charge them $10,000. No. You don't have to do that, but like so what we're going to do is we're going to do topic modeling so we can build our CSS classes. Okay, so we're using this top2vec library. We're going to star it because we're good people. And it's this guy, Danglov. Not a great name, but that's okay. So, but we love him. Thank you very much. So, how does it work? He has a really good explanation here on how this works. So, first he creates this. He uses doc2vec, which is very similar to word2vec, but it's for documents, right? So it's literally just, they have this paragraph index. So rather than comparing king to queen, you're comparing this paragraph to this paragraph, right? So it's scaling the concept up. But the one thing is those are sparse vectors. So a dense vector, when you hear that terminology, is a information-rich vector, meaning like the dimensions, each dimension is information-rich. So when we were talking about fine-tuning Llama with low rank is finding all of these independent information-rich columns, and that's actually a way you can do dimensionality reduction to some extent. But what they're doing here is he's getting doc2vec on these documents, and then he's creating this lower. He's using this UMAP thing to get these dense vectors, and then he's using HDB scan to get the dense vectors. And the cool thing about these dense vectors, so this is clustering. So he's using HDB scan on the dense vectors to find, which is a really nice, you can see the blotches that are very colorful, and he's able to get all the documents and cluster them together, and this is better clustering than like doing k-means or something. And with all this clustering, he's using the centroid, and this is a lot of people that built this. Is this a topic for the front end? No, this is a machine learning topic. This is machine learning. If you're into that, if you're cool. This is only for if you're cool. I'm just playing. But he's getting the centroid. So let's go back because I mix things up a little bit. So he's creating lower dimensional embedding. So these higher dimensional embeddings were very sparse, and he's just making a more dense. He's making a more dense vector with UMAP. Then after he does that, he gets those dense vectors, and then he uses HDB scan to cluster them. And after the clustering, using the centroid to the center of each of these found clusters, and then the word vector that's aligned with that will be the name of the topic. So as you see, these centroids, you have climate. These are the closest word vectors that are the topic. So this topic has all these words in here. So this is awesome. And then you can see how it gets used. So we're going to have to pip install it and everything. But the way it gets used is we're just going to have a file with all of our documents in it, which we have to create in a sec. And we're going to literally just run this. So that's a long-winded way of saying we just have to run this to get topics. I know nothing about ML. I want to know how casinos use our data to make predictions about our own behavior. Oh, well, that's a lot of casino stuff. Look into LSTMs. A lot of forecasting. Look into LSTMs. I mean, there's a lot of. I'm not a casino. I haven't done that, firsthand, but I would probably use an LSTM for that. Forecasting weather, forecasting stocks. Whenever you have these large fluctuations, the sequential data that isn't crazy, like language, like Transformers is super contextual. It's just awesome. But yeah, I would guess for casinos that they use stuff like that. So we're gonna get all these topics, and we're gonna get the topics, and we're gonna get the mapping with the topics and the documents aligned with the documents, the topics, and the documents are all of our metadata. All right, let's do it. Search documents by topic. Cool, nice. This part is the meat of what we want to do. Yeah, I know they definitely hire those people. Yeah, I mean, if you want to rig casinos, that's a whole game. It's a whole game. The mob will get mad at you though, definitely. All right, so let's do it. Let's get into. So first, whenever I set up a Python environment, I get my module virtual environment, and I create an environment, and then I wait because for some reason it takes a bit to do. Why is it taking this long? That's dumb. Okay, and then let's see, I activate the environment by loading this activate. So when you see source, because a lot of people, you guys gotta understand, whenever you see source, I just catted this environment because a lot of you guys probably use the source command, you don't know what it is. So I'm not assuming that, but I'm just saying you may have that experience where you're doing stuff just because a tutorial said it. Source is going to be running this bash script. That's the best way to put it for you. And then so this is a bash script that activates our Python environment by really just exporting some variables for us into our bash session. And so now we have this environment in our bash session, and so everything we run, every time we run a pip command, we're mapping that pip command to our virtual environment, and we're going to be installing. So the reason why I do this, so what's this called? So we're getting top to vec. Top to vec is such a good word to vec, doc to vec, top to vec. These are things that businesses immediately will need. If you understand how things like this work, you could just someone can complain to you about their company and you'll just be like, oh wait, especially when it comes to information retrieval, this is huge. It's huge. So let's pip install top to vec. Let's get this going. We wait because we're doing ML. Nah, we're just pip installing. It's not 10x to wait. If anyone's wondering why I say 10x so much, is that 10x is this meme in software engineering where people have been sort of saying oh, I want to be a 10x engineer. It really just means a super good engineer. Hey Reed, what's up? How do you hunt interesting GitHub repos like this? Well, I know this from my buddy. My buddy Matt told me about top to vec, and I also just knew about word to vec from learning about machine learning and learning about skip-gram models. And if you learn about word to vec, you're probably going to get exposed to doc to vec and top to vec, which are utilized in GenSip. But really, to find stuff like this, I always just I always just Google search stuff. Notice how it's installing HDB scans. That's what it's going to use to cluster. And there's DB scan, which is clustering these dense vectors, but the H is sort of making it so we can do them of variable size vectors. Yeah, like whenever you're like, I'll like be trying to deal with a problem, and I'll eventually just like find out about stuff like this, or I'll just be talking to someone smarter than me and they'll point me in this direction. But yeah, the 10x thing is so funny because like, wow, this is taking a while to install. But the 10x thing is so funny because people always on Twitter will be like, oh 10x isn't real, or they'll be like, don't have imposter syndrome. Like, no, like they try to make it out that people aren't actually really good. I don't know why. No, there's people there that are better than you. That's a very humbling experience in life. It's like the end of Dragon Ball Z where Vegeta looks up at Goku fighting Kid Buu and he's like, Goku, you are the best. You have to have that moment in your life. You can't just be like, oh no, like, I'm actually the special boy. And everyone else is wrong. It's like, no, accept. Like, there's some people are 10x, some people aren't. It's fine. Which MacBook Air you got? You like it for Deb? This is not my ideal laptop setup. I'm going to buy a new laptop soon. This is I like got rid of a actually good setup. This is a cheap one that is the best for the best bang your buck that I could find.
It's like a 2015.
Yeah, it's 2015. It's a 2015 MacBook Air. It's like these 11-inch. Yeah, it looks like it's 11-inch. Let me see. Yeah. It's like a really small one. I hate that term because of Greg Cardone. Oh yeah, Greg Cardone is such a goofball. Of course he says that. That's so funny. He's such a goofy man. You gotta double your money. That's more what's it? Valuetainment. No, but I like it because it's just like it pisses the right people off. Wow, this is taking a while. Oh, it's actually getting a lot of stuff though. So that's interesting. And also notice, like, I always use virtual environments, so now my other projects, like, this is isolated in this environment so I can now run pip freeze and I can pipe it to a requirements txt file, which you gotta do. And let me cat the requirements file, and now everything that I need for just this project is now in my requirements txt. So if I share this with someone, they can have everything in my requirements txt. So like, if I wasn't in a virtual environment, then I'd have to set things up in a way where I have to, like, when I pip freeze, I might be getting everything that in all my Python repos that I have. Okay, so let's actually use this top to vec thing. Well, first, let's actually like write this well. So let's actually make like a class that's like topic generator. And maybe, so what we're doing, if you're just joining now, is we're using this, we're trying to create a CSS framework so we can make the tiniest, most effective Webdev LLM, and it's going to be set up in a way where I want to convert my crazy style embedded like dataset for my Webdev LLM to be semantic and to have semantic classes, so that our tokenizer, when we tokenize this and put it in, fine tune it with llama or whatever, so that the contextual learnings that happen in the transformers, it's going to learn about news and everything more. My friend swears the new Mac efficient engine MacBook Air made him 10x. Yeah, a good laptop will do that to you. So like, I actually don't know how I'm setting this up yet. So like, Also, understand we're doing this so we can execute this as a main module. The interesting thing, I did that the other way around. But the interesting thing about this is I'm realizing, let's do some scaffolding first. So I want to be able to load the data set right here. And this is just going to do this. We're just going to load the JSON file for a clean data set. And we're just going to get each data site item and we're going to get the metadata on it. And we're going to use that as a document and pass those documents. So this is actually going to return, let's just say load documents. It's fine. And let's just pass in like a file name to it. And then we'll just set up like documents equals this. And, you know, really, there should be quarks for passing the documents through. But don't 10x devs only use Linux? Yeah, it's true. So I guess I'm only 9x. That's true. I haven't run parallels since I was in years. I really should. Ubuntu is so much better for development, especially once you're using these C distributions like Python. Because like every problem that happens in C is way better. It's way better dealing with it outside of Mac and Windows. So Linux. Because they're so like they're just like, I don't know, it's so funny. I was like giving Steve Jobs so much props. Let's see, load documents, so much props on our Tech Bro stream, but like, yeah, because they did, like, Steve Jobs did kind of it's cleaned data set .json. Steve Jobs did kind of like start. He really did create the rockstar engineer like culture. Not him personally, but he did sort of with the homebrew club revolution that he was a part of. Like, he was, love or hate Steve Jobs, he did bring that culture, that like rockstar energy to Silicon Valley that led to people actually like kind of wanting to do this stuff. Love him or hate him, like, yeah, he's like kind of a psychopath, but who isn't? What is it? JSON load? Hold on, I always forget this. Load JSON file. I gotta like clip that and make that like a Word2Vec explanation. I think Word2Vec's so important. It's like so crazy important. I feel like it's such an important thing to learn. Yeah, it's JSON load. Yeah. Oh, we have to create a file object. Okay. So file name, and then let's load the data. Let's pass the data here. And we can actually, before we load the data, just so, because I don't want to add, so this is why it's good to learn about stack and heap. I don't want a ton of data stored in the class, because it's going to auto garbage collect when I return here. So what I really should do is, rather than just, because I have a ton of data in this data object that I don't need, because it has a metadata key and an HTML key, I'm gonna remove the. I'm just gonna map the. Let's see. I'm just gonna map the metadata info into the documents. Lambda. Is that? Let me look up map. I'm pretty sure that I did map right. Hold on. Let's do this. But I don't have to look it up. I think that's fine. But I just want to. I don't want to also load all that other data, because I want this to actually like not. I don't want there to be an excess of like 10 megabytes in the 20 megabytes in the in memory. So you got to think about things like that. Finishing Next.js project, gonna hop into ML and Python. Nice. Next.js is actually pretty cool. So I'm gonna load it up with this empty, just to give us the option to do this if we ever wanted to. Yeah, I think ML is like one of the most important things to learn. I mean, that's such an understatement. It's such an understatement, right? I was like, yeah, I think it's important to learn machine learning. It's like, yeah. All right, so we load the documents, and we now want to do our top to vec stuff, which we have in here. So let's import top to vec. Let's hope this works. I think this uses gensim, and dude, gensim, I have such a love and hate relationship. Let's see, load documents. How should this work? So we want to actually, we can do this. And I think we can just do an empty documents here. That's fine. And then here we can actually say, we could just, let's see, load documents into model. Let's just do init model. And then whenever this runs, we'll just say self.model, and then what do they say? They just pass they pass this, and oh no, load, not bad. Oh, you know what? Let's just not even do this. Let's just do this. Yeah, that's fine. But I said modal. Sorry for interrupting you, but last question. What would be the best roadmap for someone new to ML once it's a solid foundation? So like, I can't give you good ML advice for like learning how to get in the industry, because I haven't had an ML job. I've mostly had back end, front end, web dev type positions where I'm doing, building APIs and, components and doing like extensions or whatever, like just like web dev stuff. But I can give you advice on like just in general, like getting competent enough to build your own projects. Like I would say look into, what's really good? Well, first find something you're interested in it. So like try to find like, I think something that I thought was like really interesting was like language models, because I was like, I saw what's it called? I saw LLMs and I was like, oh, like LLMs are actually really cool. And then I realized how they actually get made and what GPT actually was, and then I kind of worked my way back, and then that's why I'm so into Word2Vec, because now I'm at a point where I'm like, oh, actually Word2Vec is kind of important. Yeah, we don't need more than one worker. So then I learned Word2Vec, and I learned RNNs and LSTMs and how all those things work. So I'd say try to approach what you think is really cool, and then just work your way back and learn about the history of each of the models and how these models like came into play, like why these things matter. You could even start with like RNN. We could start with a neural network. There's a really good video on like neural networks from scratch, which is like a Python video where that's real. Look up neural networks from scratch. It's this dude, this like white dude with glasses. That's not. Now you're never gonna find it. He's a very popular YouTuber, but that's a really good video. That video, I love that. No, not a job, but for your own knowledge, yeah. Go to neural networks from scratch. Like that's all you need to start with. I think he just makes a classifier in that, but you start with that and then learn about maybe clustering, maybe learn about dimensionality reduction, like PCA. By the way, all this stuff I learned like this year, so it's not like crazy. Like I would say, go in the go in the Discord. Ask Matt about. I created a Discord last night. It's been fun so far, but he's in the Discord and he was giving someone advice. But I suggest go and look into RNNs, LSTMs, and transformers in that order. If you want to like learn about what's happening in like the greater ecosystem, and when you learn about transformers, you learn about attention and multi-headed attention. But you need to learn fundamentals, right? So you need to learn about PCA or dimensionality reduction, just basic matrix stuff too. And then as you're learning all this stuff, you're naturally going to learn about NumPy and all those things. I would say don't think of it. I never learn things, but I know what I've never done, or I always say never. I've done this like once, maybe like years and years ago, but I never just learned the technology without any context of what I want to do with it. Never. Okay, so fetch news groups, speed learn, workers 8. So let's see, once this model actually gets trained, let's get the number of topics. It's actually kind of cool. So this init model is more so train model. And this gives us we can return it. This gives us a model. Let's actually train the model. Why not? Let's just do it, right? Whenever someone says that, like, don't, they're getting you into something bad. Let's just do it, bro. It's like, why is your pants off? No, I'm just kidding. Hey, bro, let's just do it. Let's just get into it. No. Hey, bro, hey. Let's just go for it. You know, I gotta log stuff. Let's see. I'm gonna say initializing topic generator, print training the model. By the way, the training is the context window stuff. Like the training forward pass in a Word to Vec model is this context window going, and you pick the size of the context window. I don't know if we didn't actually pick it here, but it keeps going across it. So what they use is they actually use a doc2vec, which does the Word to Vec, but with these paragraph indexes. The neural network from scratch series is on Sendex. Yeah, thanks, Sam.
Oh yeah, I just like start.
Thanks. Sam's right here, but he texted in the chat. It's my brother Sam. Yeah, like that's like that neural networks from scratch is like so good. Like I saw it after I learned. Oh, you know what else is good? Andre Karpathy. His video on GPT from scratch that's great. That's so good. All you need is those two, and I think you'll learn like a ton. Let's see. So we're getting don't Python keyword argument. All right. So what? What is number.jit? I actually don't know what that is. But they're telling us, all right, whatever. But initializing the model, apparently importing top2vec takes time for some reason. I don't know. But it says list indexes must be integers or slices, not strings. Okay. I think this map didn't work. Because I'm supposed to do X. Because in my anonymous function, I named X and I was using a global variable. It's my bad. Yeah, of course. Let's see. Now, why is this taking forever? What's taking... Oh, so importing this takes time? I guess I'll print importing top to back. That's weird. In the end, I think I'm going to train it. I think this is going to be cool. Oh, whoops. Self is not defined. My bad. Just open up my mail for some reason. All right. Yeah, 10x is so real. There's no, like, you go to companies and there's people that are like, yeah, like Gary made it's always a Gary. It's like, oh, Gary made oh wow, this is really cool. But he's like, yeah, Gary just built everything and then he left. Like every company. And you're gonna tell me 10x isn't a thing. There's always some Gary. Oh yeah, Gary just like built this and then he got a job at a FANG and then left and now he's like in the mountains. And you can tell me 10x isn't real? Okay. So while it was training, it says need at least one array to concatenate. So it loaded things up, which is interesting. So it said, so it did actually, so that's interesting. So it creates a joint document word embedding. And then this is lower dimension thing, that's the UMAP thing. So you can see the UMAP package ran, and then that's where we got our error. Is because, oh wait, no, the UMAP ran fine. We just got a warning, I think. So it did actually get the lower dimension of our document embeddings, and then we're finding the topics. So remember, we're clustering HTML pages based on the content. So when it started finding when it did the clustering part, that's where things broke. So let's actually just look at this documents thing. This might be broken. It's one array to concatenate. That's weird. Is that not an array? We'll see. It's gonna print a lot of stuff, so I like to just do everything on Colab, honestly. But we're doing this, okay. Yeah, this looks fine. I mean, there's a lot of new line characters, but that's not a big deal. There's some emojis. But yeah, this is fine. So we have an array of this is the text on each of the HTML pages. Or we're gonna start labeling this. Or we're gonna get the topics from these HTML pages, label as topics, and then use those as our CSS classes for our CSS framework. Yeah, and this is all fine. So top to vex not working. This actually is fine if it doesn't work. We can do this on our own. I can actually figure out a way to do this with some k-means stuff with Word2Vec, with Doc2Vec. That should be fine, but I want this to work. I'm gonna see if what this error is. Need at least one array to concatenate the length of your array. Please check if your array list is longer than 0. So let's log the length of this. Oh, I've been doing JavaScript so much. You ever go between languages and then you're just like, what? I do that all the time. Like I'll be like going from one language to another language, and I'm just like, I didn't test anything. I didn't realize I was like going back and forth I'm just like insane. That's the dumbest thing I do. I'll like legitimately not know that I'm coding in another language for like 10 minutes. So yeah, there's 10 things. That's right. We're gonna get the same error. So maybe this document thing doesn't take it in documents. I don't know. Okay, so we load the documents from our data set. We don't have to return anything. I just want to remember just in case. It's doing something, like it appears to be training something, but then it breaks. So we need at least, so what's happening here? So compute topics. So we have this R's thing. So it's concatenating a ton of arrays, and it's saying it needs at least one array to concatenate, and they're using NumPy. And it's doing something in this VStack thing. So this is the line that breaks. The line that breaks is they do a VStack in all of our document vectors. And then it says where cluster label equals this. You know what's, so this I think what might be broken here, it might be the fact that maybe we have emojis. I don't think so. Let's split this. I don't know if this is actually going to do it. I'm just removing the new lines. And then yeah, that should be fine. I don't think that's a big deal. Let's see. Convert string to UTF-8 Python. It should be UTF-8, but I'm not sure. Let's encode it. I don't know if this matters. I'm just trying stuff. Let's see if that does anything. Crack the neck. I don't know have I had caffeine today? No, I had a coffee. I typically have a coffee every day. Or a green tea. I don't really consume a lot. Document needs to be a list of strings. Oh wait. Oh, okay. So that's not, we don't want that. But, well, it's running. Let me see. I thought that was fine. See, type. Oh, okay. I don't think we have to do this. I think I'm just that's definitely not what the issue is. But see if this breaks, to see if the new line characters had anything to do with it. I doubt it. What was this error? So let's look at what MPV stack does. But also what matters more, you see how I was able to read this error stack, and I was able to kind of sort of look through it logically to see what was going on. That matters more than anything. Being able to debug the problem and being able to, even if you're not, like I've never used VStack, but I figured out that this was the problem with the code, because I saw that, one, I was able to see that this concatenate thing happened, but I saw that it was in a third-party library. Just to explain why I know this is the source of the problem, is I saw this was in a third-party library that's being used by Top2Vec. Top2Vec's the library I'm importing, and they're using a library. And then the error is happening the error is happening here, but what I mean is this is sort of in the world we understand because we're using Top2Vec. Right? So I try to find the module I'm using in the call stack, and then yeah, I can work my way back up there, and then I can see that it happens. I know it happens in the train model line, obviously. That's like, oh wait, it happens in the load documents. Oh my god. Oh no, wait, actually, hold on a sec. Yeah, this is, well, either way, that is how you're supposed to look at it, but We actually don't care about, this is happening right in this line. Hold on. Let me just double check. Line 15. So that's the return and the load. Yeah, no, we're in, it's happening like right here. All right. Like right there. Because yeah, it starts running, training the model. For a second, I was like, am I looking at the right thing? But yeah, it starts running and training the model. All right. But clean data set, finding topics. All right, so yeah, we got the error again. But yeah, so that's a really important thing, is always find the module that you actually are using, because the error might be real deep. But try to find in this call stack, work your way up to find what you're doing. Okay, so this is the line, this is our line that's broken. We do worker 1. Maybe it's not supposed to be worker 1. Anyway, let's look at what vstack's doing. It stacks arrays and sequence vertically. Yeah, that's what I thought. So it's just stacking rows. And it says one of them isn't an array of text, so let's see why that would happen. Let's look back to what we got here. Let's see. So one of these documents is not like the other. So let's look through all these documents. Print doc. Let's print the length of the doc, because I want to get, and let's print the type of doc, or type doc. See, more mixing languages. What am I doing? Okay, let's try that. There's a lot of trial and error, and there's a lot of error. It's a lot of error. Let's see. I need to get some food, but not yet. All right, so yeah, these are all strings. So I was thinking maybe one of these wasn't a string. I realized I logged whatever, but hold on. Let's log type in Python. What is log? Oh, what? Type Python. Check. To make sure it's logging a class that's a string. And it's such a simple Python thing, but what can you do, right? Is string. Okay, I think yeah. I just want to make sure that we weren't just logging the representation of the result of the type thing, whatever. But all right, we're fine. So that all is fine. Maybe it's because some of these are big. So for whatever reason, maybe I'll just like do 8 workers, because that's what the example is. I don't even think I can do that here. We will get there. If we can't get top to back working well, we will build our own top to back. I don't care at all. Get it done. Okay, so creating lower dimension, embedding. Also in these streams, you can interrupt and ask any question. I don't care. It's not. I'm used to working and talking. Like when I'm working, this is just going on in my head. Okay, so when I compute the topics, pass in this, and it does this cluster labels thing. And let's look at this error again. So all this is doing, this VStack thing, is just combining arrays vertically. So it's just adding rows together. And it's saying at least one array to concatenate, so it's not actually, you know what this probably is? You know what the problem is? This isn't what I think it is. I thought it was an array. They said it was an array of let's get sklearn datasets. Do I have that? Let's look at the dataset they have, because I thought it was just an array of strings, but I guess not. I guess not. Always look at the docs. And that's it. Ah. Yeah, no, just let's see here. NumberJit. I don't even know what number is. What is number? Part of why I know stuff is because I will just randomly look stuff up I don't know out of insecurity. It's just a Python compiler. Okay. Why is this taking a while? It's so weird. Okay, so let's give some space. We're also getting these like weird errors every single time we run number. Okay, cool. It's data. Oh, so they pass in an object that has data in it. Okay. Oh, and then we're doing the wrong thing. It's an array of documents like that. Hold on a sec. Oh, okay. These are supposed to be an array of arrays, but I thought I could just cluster a ton of. Hold on a sec. So this is getting 20 separate news groups. So a data set that's a collection of a lot of different documents. 20 different classes. I don't care about that. Like, what? Cache folder. Oh, you know what we have to do? Let's split each web page into the new lines. Okay. Let's actually return the split of new lines rather than joining it. This has to be an array of documents and documents. And then they make document vectors off of each document, I'm pretty sure. So we'll use the new lines on each HTML page. Pretty sure that's what we need to do. Pretty sure. We don't have to do this again. We'll just comment it out. It's an array of arrays. How did I miss that? Okay. Where's the top of this? Oh my god. I need a better search for my terminal. Gotham needs a better search terminal. The world needs better class coder. Alright, so and I'm gonna give it to him. Let's just search for data. I just want to look at what it looked like. Oh, we had all these things. I forgot about that. We solved that problem. Alright, whatever. Doesn't matter. Oh, actually, let's do that. Oh, okay. Whatever. So the result we got, document needs to be a list of strings. Yeah. That's what I thought. It needs to be a list of, yeah, it does need to be a list of strings. Alright. Let's log this again, and then let's, what is it, exit, like that? This is life. Can't always get what you want. If you try sometime, you just might be 10x. Become. You know someone's 10x if they hide their power level a lot. It's so dumb. It's true. No, I need to find the top. What? No. Okay, alright. So, let's do this. This is so dumb. I get it. I know it's dumb, but let's just do that. I just need to make sure when I'm scrolling up I can easily find this. So this is... I could have sworn this is... Yeah, it is an array. We make sure our data is similar to their data. Okay, so it has, yeah, it has an array of strings. So it is just an array of strings. You fascist, what data set is this? What the? Alright. Yeah, it is just an array of strings. So what? So their data set is just an array of strings. Our data set is an array of strings, but we're getting an error. So let's go back to this error and let's look up top. This is a fairly used repository, so I think we'll be able to find something here. Let's see if someone's referring to it here. Yeah. This guy's using the same thing. Nice. Did anyone reply? You need to use more docs and unique words for it to find at least 2 topics. Just multiply your list by 10 and it works. Oh, okay. We're not using enough data. So let's do this. Let's multiply our thing by, so dumb, but let's multiply it by 10. Because yeah, we're not using a lot of data at all. That's what's happening. That's because we're using test, I mean not, it's test data, it works, but we're using a really small amount of data. That's okay. It's okay. I feel like the best part about solving problems is that moment where someone else figures it out for you on Stack Overflow. When a better man than you on Stack Overflow solves the problem for you, that's what coding is. Because the real black pill for software is realizing that no one knows how to code. Alright, so we did it. We trained the model after we dealt with an issue that was really weird that we should have just looked up a lot earlier. I want to look up the number of topics that I got. So let's print. After it runs this, let's just print number of topics. Topic count. Yeah, I mean, I don't know. I don't know why. What our topics are gonna look like when we multiply our data set by 10. Oh, you can multiply arrays like that. It's kind of cool. All right, so now let's get the topics. So generate word. We don't want to generate word clouds. Search documents. We're going to search by topic 48. A topic that appears. So I just want to, what I want to do is I want to get, like, for each HTML item, I want to be able to get, let's see. Turns search. I think I do want to get the top 5 documents per topic. How do we want to do this? So we have to label each document by its topic, and then we have to store. So back to what we're actually doing. So we need to now get, in order to, so the first thing we have to do is we have to cluster the HTML pages. So we kind of did it, like we generated these topics. We got to figure out what that looks like. We gotta, so, So we have to get the, you know what I should actually do is just, all I need to do is update the data set with topics for each, with the labels for each HTML page, and then we could just get into this, the CSS, into making the CSS framework. Well, we already are right now, but I mean actually like trying to find common CSS classes. Let's actually do that. But for now, let's get these topics per doc. So how do you, so is there a way to search documents, topics by document? Can we do that? Score. Search documents by keyword. Search keywords for word and space. No, I don't care about that. I want to be able to get a document and then give me the topic for it. Generate word clouds. Search topics. We're going to search for topics most similar to medicine. What do you think? Get the number of topics. You know what we probably can do is I can just run a loop where I just get each topic number and I loop through it and I get the top 5 documents related to the topic, and then I just pop it off the list by string matching it. That's such BS. I hope I don't have to do that. I hope I can just, why can't I just get all the topics related, to get the closest documents related to each topic? How do I do this? How do I do this? Oh, do they give us doc ID when we do this? Yeah, we do. Nice. Okay. So let's do this. So let's get, and I think that the doc ID should be the same as the index there, should be the same as the index in the document. The index in our list that we pass in the documents. So let's get topics per doc. And this will just be a mapping of like 0 to a list of topics. So let's do self model dot. So we'll do for topic in range 0 to model get topics for topic ID, and then we'll get the topic ID, and we'll get 5 docs, I guess. I know we only care about 1, I'm pretty sure. This kind of sucks. Because we're gonna have to loop through it, and we're gonna have to try to figure out which doc matches with the, like, we're gonna have to get the highest score. This kind of sucks, but so we're gonna make a doc map, doc ID score map. And this is gonna have to be for each ID with the topic with the highest score. Is that how we do it? You know what? I'm pretty sure that doesn't matter. Let's do number of docs 10. Yeah, we want to do that. So we only have 10 docs, right? So, or we can actually do self documents length. They should have just had this built in. So we're trying, just to be clear, we're trying to map the top topics per doc. I thought that would just be built in, but whatever. So for each topic, we're getting the topic ID, or we're getting the scores for all the docs by, so first let's just log. Let's log document IDs, comma, document scores for each, and let's actually break, because I don't care about what that looks like. And let's run topic gen for that. Keep doing semicolons. I think we're good. I think we should be good if we do that. So we're actually kind of close, because actually now when I think about this, generating the CSS framework isn't even going to be hard once we have the actual topics for the data set. Because all we need to do is it's going to be a lot of processing, but we need to get, for every embedded style we have, we need to find all the common styles. Also, if someone really wanted to do some awesome stuff, they should use what we're building today off of, like, this is like maybe not $1 billion idea, but this is like a quality $100,000 idea. But they should train this off of like a ton of, oh nice. They should train this off of a ton of websites. Oh, there's only 3 topics. That's fine. But they should train this off of a ton of websites so that you'll be able to just have like a super semantic CSS framework. So I want to build this with scale in mind, so that you could just keep adding data to this, and it'll just be so supercharged that you could, if you actually, as long as we keep it within a few megabytes. I know it's a lot, but we're just doing this to make supercharging our Webdev LLM like so good. But if you could actually make like a really powerful CSS framework that's semantic with what we're doing. By the way, we're labeling the CSS classes we're clustering the HTML pages and labeling them based off of the topics we're getting in our cluster. All right, and now we have to figure out how to map the topics to the HTML page. By the way, if you have any questions about job stuff, coding stuff, let me know. I'm all about it. I don't really care. Why are the doc IDs so weird? What the? Oh, you know why? I totally forgot. We multiplied it by 10 so that they could actually have enough data to get topics. So we're gonna have this. So there's 99. No, there's 100 things, And these IDs are indexes, I think. That's fine. That's fine. We're good. We're good. We're Gucci. I say we're Gucci. Why did I just say that? Let me just make sure the math is right. Dang. Do they not have this built in? Let me just, before we do all this to figure this out, do they not have this built in? I feel like this definitely should be something built in to just map each document, to just get topic for a document. Like I feel like that's like kind of obvious. We're using top to back, by the way. So we can do this, but like we could just use all the document words as keywords. Oh no, this is search documents by keyword. We could do that, but like I don't want to do that. Get topics, sizes. The number of documents most similar to the topic, get topics. For each topic, 50 words are returned in order of similarity. You know what we can do instead of this? We can do it the other way around, and we can group together. We can loop through each topic's list of words, and then see how many, if a lot of them occur. It kind of sucks, but if a lot of them occur in one of the documents, then we could say it's a part of that topic. It kind of sucks, but for each topic, cosine similarity at the top. I just kind of want to map all the documents to each topic. I think. Oh, this is fine. Yeah, this is fine. This is fine. Let's do this. Let's oh yeah, we can do this actually. First, let me run this again and get the documents so I can see what it looks like. This could actually be really cool. I'm excited. I've been trying to figure out how to make a tiny Webdev LLM for like months. It's why I know all this ML stuff now. I'm like, I never want to code again. I want to do a stream where I try to see if I can actually like code. If I could pretend like I don't know how to code, and well, yeah. But and like see if you can actually use ChatGPT to get a job. What if I did that? What if I like made sure I applied to a job, and through the whole process I never write any code? All right, here are the. So looks like these are the docs. It's this doc right here. So they don't actually, they just give you the text. And which is fine. It is fine that they're just giving the text, but and it's for the second thing. So it's for this number 2. I just want to make sure this ID matches up. So what's number 2 in our let's just log some space here. Print doc print. I just want to make sure their indexes don't start at 0. I don't know if they do or don't. Who knows? Well, this is what I do on Saturday night. You guys are destroying. I'm like that kid. I'm like, you guys are destroying your brain cells. I'm the special boy. While you guys are out partying, I'm creating the web. Okay, so carousel, home, cover, home. Oh, okay, so 2 is the third thing. So they start at 0. Their indexes start at 0 for these IDs, so we can use this doc ID as an index in self documents. Okay, so let's make this algorithm. Let's map all these things to, it's not that complicated. It's just, we just need to map these things to, we need to get the highest score thing, and we need to keep using this map. So really what we need to do is we need to loop through these document IDs. For doc ID and document IDs. So we're going to get the current score ID to the topic highest score. This actually should be a, you think? It's going to be, we want to get the highest 3 scored things. What do you think? Yeah, we want to see, we want to get the highest 3 scored things. So let's do this. Or we want to just keep giving it higher scores. So I'm like trying to think about how to map these to the closest topic. Yeah, we just want to map it to the closest topic. So we don't actually care about storing anything. So this, we're going to map this to something that has highest score, comma, the label, or the topic name, or like the score. So we want to save the score and the topic name. We'll map this later on. And we'll map the map keys into an array, a list. But we want the we want to store it like this, so that as we're looping through this, we can keep the state of the last score. You'll know what I mean. You'll know what I mean. So for every document ID, after we get the top documents for each topic, we want to be able to check if there's a current score in the map. So we want to say if the document ID is already in our score map, get the current score. If the current score is greater than, hold on, what does this object look like? I know I logged it like right here. Where did I log it? No, it was way before then. Or way after then. Let's see. Wait, what? Oh, I can't find the log. I know there's a 99 in here. Oh, that's not enough. 99 space. Is 99 space gonna come up? No. This is from another video I did. Oh. Or a video. That was actually a tutorial I was doing. Yeah, I do tutorials. Well, so what? Okay, so let's get the current score like this. I'm gonna assume these scores are just an array. This is a weird data structure they're giving us. They're giving us 3 separate things. One of the documents in a list. So we want to enumerate this so we can get the index, and then we want to, oh wait, is that the other way around? But we want to get the index of this so that we can get the score, and we want to say if the score is greater than document scores I, then we want to set this score, no, whoops, to document score I. And then what actually matters is we want to set the topic name to documents, or the two. We actually want to just do the topic ID. Because actually, I don't think we're just getting the topic ID for now. We have to get the name from the ID later. Can we actually get the topic name from the ID? Is this API is a little sketchy. Topic scores. Get topics. Yeah, we can. We can do it like this. Kind of weird to do it like this. How much RAM do you have in your laptop, bro? Not a lot. Yeah, I need a new laptop. Yo, cash at me. Alright, so let's get these topic IDs. And we don't have to, we could still break because I want to test when this is broken. And so let's go and let's print if, let's fund my new laptop. Alright, so for this, does that work? Yeah, that works. So we're loading up, we actually want to do this per topic. Yeah, we want to do this. Wait, do we want to do this per topic? Do you smoke grass? I don't smoke grass. Oh, you like my content? Thanks. What video do you like? No, I don't even drink anymore. I used to drink. I stopped like a year ago. Or has it been? Yeah, it's been a year and a couple months. Yeah, any suggestions on content? Because I'm gonna stream a lot. I love streaming. This is because all this stuff I'm streaming, the conversations, like the build stuff I'm building, this is all stuff I'm already gonna do. Find something that you just would do and then just put it on the internet. You know what I mean? Like, literally just put it on the internet. It's so great. It's like, it's so obvious. I need more RAM. I do actually need more RAM, like legit. Not on a, let's see. I would do tutorials or setting up for the first time. You do tutorials? Dude, are you high right now? What do you mean setting up for the right time? Setting up for the first time? What do you mean setting up for the first time? I probably will, by the way, when I ask this, I will probably make a video literally like tomorrow based on what you say, so. like I'm probably just gonna do what you say. Anyway, okay, so I'm gonna make an else statement. Well, actually, we want to say, we want to do if, so if we actually don't want to do anything if the current store, but we want to say if the doc ID isn't in. Oh no, it's all good. I'm just messing around. Just messing around. It's all good. This is just my humor. I grew up in a way where we just make fun of people. All right, so the doc ID score map, if it's not in that, so if we haven't loaded up our map yet, we want to just load it up with whatever this current doc ID is, with an object that has this current score, or I say object, but a dict that has the, I'm a child, it has the current score and it has the ID. Remember, we're trying to map these IDs. We're trying to find the highest matching ID per, like each doc's closest topic. This is a weird way. This isn't the best way of doing it. How much you make? Dude, I started streaming like a month ago. I've actually been growing pretty well for that, which is cool. But like, I don't make anything from it. It literally, today it's been a month, or yesterday. This is not my revenue stream is like contracting and my like mentoring and tutoring stuff. Mostly, by far, contracting. I want to make something to translate strings in various code bases and into common languages. Something to translate strings in various code bases into common languages. What do you mean? So something that'll automatically. When you say common languages, do you mean programming languages? Talk to me, Kevin. Talk to me a little bit more about your idea there. That sounds interesting. All right, so I want to see if this actually. After we break, I just want to see what this. Let's not break. I want to see what, after we do all this, I want to see what this mapping looks like. We want to map, and by the way, in order to get TopDevec to work, we had to have duplicate our data set by 10 different things. You want to make something that translates strings in various code bases into spoken languages. Interesting. So you're going to be analyzing source code, parsing out the strings, and then you want to convert it to those strings to something like an English code base. You want to convert those strings into Spanish. That should be fairly simple. Like, look at this file right here. Bang. Notice something? Bang, bang. So when I think of things like that, this is what I'm looking at. You notice something? Every time a double quote starts, it ends. That's a closed loop. You don't have to, the logic is simple. You have the way you parse the string is you have a loop where you go through each character, you start a cursor. When the quote starts, you get the string per character after until another double quote starts. I can't think of any. So you'll have to check and see this, right? You have to remove all comments, remove all doc strings, right? The code is already structured where every string is something like hello and already parsed actually, but the issue is getting context of the strings based on the code. Oh, interesting. You may want to use a model for that. You may want to analyze it. Context is hard. Context is hard. Word2Vec, I may be misunderstanding, but Word2Vec is very good at context. What I'm using right now. We're using TopDevec, but in terms of analyzing context, it's really the scope of the data you have and the value of the embeddings you have with that scope. So it's like, what's your data set look like? That's interesting though. Okay, so importing TopDevec. Let's actually see if we get this ID score map, because I want to have every ID, and I want to have. Oh, we don't want to print that for every single one. I want to have every ID mapped to the highest score. I think we're good for that. I think we should be good for that. Let's see. So let's run this. Documents. So they're saying, like, they're turning the document vectors we have in Word2Vec to dense vectors, which is very cool. Because you don't want to be doing clustering on a lot of sparse vectors. You want to get a low dimensionality space. Okay, cool. All right, I think this is actually what we want. Nice. Wow. Cool. There's only 2 topics. All right, but this is what we want. So the thing is, we have to divide each of these numbers. We have to, like, it's kind of dumb, but we have to, like, I multiplied the data set by 10. So we don't care about anything other than 0 to 9. So when it comes to these IDs right here, it's kind of dumb, but actually let's do I just totally forgot. We want to do length of this times 10. So we want to get all the docs and we get the score of all the docs, so that all the docs, what are the prerequisites for following along? Yeah, so I would say watch the beginning of the video, honestly. But I'll just talk about it now. So what I'm doing, this is a video. I have 2 other videos where I do like the first part of this. Now I'm trying to supercharge it and actually like, I think this is gonna make it work really well. But a little overview. I'm building a tiny Webdev LLM, which is, what I mean by that is I'm fine-tuning an LLM with a data set that is perfect for writing code. I think that's my guess. Oh, we got an error. Topic 0 only has, oh, interesting. So we have to find the max amount of topics, so we can't make this a variable. But so what I'm doing is I have a data set where I get HTML pages, and it's just for static HTML pages, where I web crawl and I scrape a ton of web pages and I convert them. And I have oh, did I not link the GitHub in the video? Well, if you look at one of the other videos, if you go to my GitHub, there's a tiny Webdev LLM script there, repository, and it has all the code here. I'll link it after the video. But yeah, so it's a web crawler. I embed the style. This is what makes it good for training in a transformer, in my opinion, is I'm embedding the styles in each element. But there's a problem with that. And one, it's super big. I have a way of compressing that by diffing it with default styles. But 2, which I'm addressing in this video, is I want to convert those styles into just CSS classes that are semantic. So they have some term in it that's to do with the meaning of the web page in comparison to what the question will be. So our data set is going to look like this. So it's like tiny Webdev title. This is like the title of the page you want to generate. This is going to be a question later on, which is going to be another video on how to label these. So I want to label these probably with like an LLM. So it'll be like, this is a login page that's looks like Facebook, right? And then after this token, we're going to put the code, which is going to be that compressed HTML. Like the strings open menu means something different. How do you plan to query it eventually? So like this. So like the query will be this. So I showed a little bit. Definitely check out my other videos where I'm just look up the tiny Webdev videos I have where it's like fine-tuning Llama with it, because I show the generation is just, I don't know if you can see what I'm highlighting, but it's not included this. So the generation, I'm using a casual LLM, using Llama, so I'm giving it this context, which is the title, and I already trained it to actually generate HTML, to know to generate HTML after this token. But it's not good, and I don't have enough data, so I need to like offline get a ton of data and like actually make it work. But this way I think we can, and I'm using QLoRa to train it too. But I think I can, with this, we can probably, with enough data, I think you could actually train GPT-2 to code websites. And it's not going to be perfect, but I think it's a good way of testing out that we don't need huge LLMs to solve problems. I saw the one where you got the HTML from HN. Oh, nice, yeah. By the way, if you want to get good at web scraping, I have like a ton of web scraping videos that I've been doing. In general, Puppeteer. You can also just look at this code base. Puppeteer is really good. You can set up a VPN in the proxy and store cookies. I actually haven't had that on video yet, but I love Puppeteer and Node because it's very easy to do to inject JS into the page, which is the best way to scrape, in my opinion. So you're gonna say, give me a website about X, and it should look like, yeah, exactly. It's gonna be exactly like that. So it's kind of like So, and you can do things like this at a high level, but I haven't seen very good creative web designing with things like GPT-4, and it's crazy to me how much parameters those models have. So I think if we can like really focus on this task, we'll be able to train a model that can do this really well at a super small level. And so that's really the overview of the project. So let's see if this is not perfect what I'm doing right now. It's just because there's no function for, and yeah, hopefully one day there is. I actually do think the concept of a gym with enough data, the concept of a gym would, in the assets. So that's another thing, is this is ignoring SVGs, right? So that's a complicated thing. I want to have an SVG Webdev thing. If this works well, it'd be really cool to fill in with SVGs and to use, and that would probably be like a BERT-esque model, where we can actually like fill in. We could train like a hyper focused, and there's already models that can do this, but I mean a focused model on it. So we have to make this 29. And what I mean is SVGs, the reason why I say that is because if you're making a gym website, then you have to have gym like images, right? You have to, so some way to like actually, so eventually after we do this well, I want to do something where I can generate assets using these sites. And then after that, and if we can make these models, like part of the benefit of me having this crappy computer is that it's incentivizing me to make like super fat, like efficient stuff. But eventually if we do this well, we can have a tiny React component generator. That'd be interesting. Exactly. All right, let's see if we can, let's see what this looks like. So now we're mapping, so we're clustering the HTML so we can get the topics. We're going to use these topics as the names of our CSS classes. Hold on a sec. So we keep having to do this. I gotta find a better way to deal with this. Let me think. So we have to, for each topic, you know what? Hold on a second. It's a better way to do this. We want to do get topics. Topic IDs. Yeah, we don't want to do this. We want to do get topics, and we want to say, yeah, that's what we want to do. We want to enumerate. Let's not do a range. Let's enumerate on topic words. Or no, on topic nums, which is an array of the num. Would we have to enumerate on that? I think it starts at 0. Let's just do range, and then let's do get num topics. But I think that's fine. But what we want to do is let's do topic nums, and let's get the I index, and then instead of this, let's do the length of topic. We're trying to dynamically do this. Why don't you check the size of the topics? Yeah, no, you're right. Dude, Matt, I'm doing that right now. That's so funny. I know, dude. Matt gets it, because that's literally what I'm doing right now. No, wait, Matt. Do you know how I can? We're trying to map. This is the only way I can think of. Model. Yeah, the model already has this. Yeah. What is that? Please tell me, because I don't want to write this. This is so inefficient. I couldn't find this in the docs. Because this is very inefficient. No, I know that. I have model get topics, but I want to get the mapping of documents to their highest scored topic. for each document. No, I know that. No, that's what I'm doing. Yeah, that's what I'm saying. Like I'm doing like the get topics thing. Oh no, I don't want to do 77. But yeah, I just copied this. But so you want break at that line? Break at what line? I forgot there's like a latency thing. No, I know about the get topics. What I mean is I want to map the highest scoring. Line 37, you keep breaking? What? What do you mean? Oh, I see what you're saying. Okay. You're saying I don't need a loop, is what you're saying. The thing is I need to figure out how to map the documents to the topic. Like I need to get the highest scoring document per topic. I mean, I need to get the topic that's highest scored per document. Does that make sense? I need to, for each document, find a way to Matt, you gotta, dude. Just say it in the chat. Please tell me this, please, because I don't want to do this. Local variable I. Oh. We don't have an I. We have a topic ID. By the way, Matt Matt knows what he's talking about. Do you have? Can you just say it in the chat? By the way, this is pair programming right here. I wish I could just get you on the stream. One minute, I'll oh yeah, link the doc so I don't have to write this. Because I need to, so what I need is I need the highest scored topic per document. And I'm literally, the way I'm doing that is I'm getting the highest documents for each topic and I'm just finding it that way. I didn't see anything in the docs that said anything against that. Let's see. Need at least one array to concatenate. Now we're back to this. Hold on a sec. Why would that happen all of a sudden? Get topics per doc. Need an array to concatenate. Okay, so I don't. Why would this randomly come up? Also, I don't need 8 workers. But let's see. Training the model, and then on this line, why would this happen randomly? Oh, you know why? Because it's probabilistically finding the topic. So that time it didn't find any topics. This is what happens when you use test data. Because there's like this data set's so small. Let's run this. Alright, so training the model. Let's see if we get the same error again. Getting to a lower limit. I can't explain. It's in chat. Matt, please try. It's not too much to type. Please try. It's okay. You don't have to. You don't have to. We can also talk about it later. I can fail now, and let's just talk later. Original topic 1 only has 48 documents. Okay, so I have to let me actually return here and print the words. I want to see what all this stuff looks like. Topic words. Matt, please try. No, it's okay. I need, like, there has to be a way. Alright, let me log all of that. You have a misunderstanding of how the model works? Okay, so let me think. So what's the misunderstanding? Matt, I need to know what I'm misunderstanding here. Matt, I need to know. So I'm getting isn't that how it works? Like, I'm getting the topics from the documents. There's documents that are in that cluster. I just want to get those document IDs. Matt, okay, I don't know if anyone can hear you. Hey, what's up? Matt, what do I need to do? But how do I get the documents in each cluster? Yeah. Oh, yeah. I already did that. Okay. Dude, can I just get you on the stream? That's okay. No, that's okay. Oh, that makes sense. By the way, he's my AI guy. That makes sense. Okay. You could have just typed that. Dude, Matt, you did just save the stream. But let me log all this first. Okay, so the topic words, you have to have an AI guy, by the way. If you don't, oh, okay. Dude, that makes so much sense. Okay, so there's these topic words. Oh, okay. These are the top 50 words per topic. And then I get the word scores. Dude, that makes sense. So these word scores are interesting because, and then the number of topics. Okay. So let's go. Let's see, how many words are there here? Alright, so these topic words. Okay, so there's 2 topics. And the topic I don't need this anymore. Yeah. What was I doing? So the topic nums. Hold on a second. I need to do this to get the topic number, and then I need to get the length what was the error here? Topic words. Under topic ID. Let's see. So I actually don't need to do this. I can just loop through this array. And then, Matt, stop me if I'm doing something wrong, please. Okay, so I think that fixes up some of it, but I just want to see if this breaks. Am I still returning? My bad. So what I didn't understand is that the topics are like the features here. All right, let's see. Please, I think I'm gonna get an error though. Yeah. Invalid number of documents. Original topic 1 only has 21 documents. Oh, right. I'm doing the number of words. What am I doing? That's so funny. So I need to get I don't know why I was getting the word count right here. So what I need to get is just let's see. How do I get the original topic count right here? Let's look in the docs. How do I get the amount of documents? Oh, I just get topic sizes. Dude, I don't know why I wasn't listening to Matt before. Alright. I don't need that. I don't need that. You make a lookup table? Yeah, thanks. I found it like right when you said it. Okay, so oh wait, the size is this already an array? Oh no, this is an array of the sizes. This is so weird how they made this. And then I use the topic ID as the index to get that. Okay. Yeah, so the lookup table I'm doing, I don't know if that's what you mean by the lookup table, but I have a map of the doc ID with the score and the topic ID, which is, I'm just saying, is the closest word or the closest topic. And then I'm gonna, as I loop through this, I'm just gonna keep maxing. It's just a max function. Is that what you mean by lookup table? Yeah. Okay, cool. Nice. Dude, Matt just saved the stream. Dude, if you didn't I may have just nice. Look at that. So there's a lot of documents here because we don't have a lot of data, so we had to do this. We had to multiply it by 10 just to get topics, which we'll remove once we actually get a real data set. So now I got to deal with that little hiccup, and I have to only get 0 to, the index is 0 to, so let's say 4, 0 to, we can just use a raw const right here. 0 to 10, Okay, yeah. But for I 0 to 10, we get this, and then we can get the document score. So this document index is actually, let's see, topics per doc. How do we do this? We can do is, let's make a function to save docs, save IDs to docs. So what we want to do is that our document has metadata key with the HTML, and we want to add another key, which is the topic. Save topic to docs. And actually, we can just, let's do this. The object's doc ID score map won't be that. It'll be a doc ID token topic map. And now this topic map, we're just shortening the map. That's it. That's all we're doing. We're gonna garbage collect the old values. It's good to get used to garbage collecting old values that you're not gonna use once you're done processing. What I mean by that is we're not gonna. So I could have just set this whole thing to the context, but I'm not. I'm only setting because I had to pad the data. Like I had to do this with our data because it's so small for now. This isn't. Eventually, I'm gonna have to get a data set that has 1,000 things in it or something, or 1,000 websites, so we can cluster. Now we just have 10. But okay, so this, when we save the topics to the docs, all we want to do is in our map, we want to, for everything in the map, for the keys in the map, we want to get this topic, and we can actually just get the, oh, you know what? Documents, we only load up the metadata in the documents. You know what we can do is we can load, we can pass in the file name of our data set, and then we can load it up in this function just so we're being memory efficient. So I'm all about being memory efficient. So, because our data set's big, so I only want it to load up in the context of this function right here. It's good to think in terms of what's getting stored in the stack and what's getting stored in the heap. We're dealing in stack memory right now. So let's go, and what I mean by that is I could have just saved this to, rather than loading this up again, I could have just stored this when I'm in my constructor and just had this always exist. But this is 20 megabytes. So I'm going to have 20 megabytes in memory stored. Does that make sense? And I don't want to do that. So I'm going to create and destroy here. And I know it's Python, so, Python's going to garbage collect. Or it's okay. But for classes are not optimized. Okay, so what am I doing here? So we don't want to do this. We just want to get this topic. Let's see. So we actually want to just get the token. Not the token. The topic. Oh, we're just getting the topic ID. I totally forgot. We gotta get the topic word. How do we do that? So there's the topic. So what was this? What did this look like again? So it has all the words here. Oh, we don't have the word IDs. Dude, I hate this API. the way the API. Oh, it's just the topic ID. My bad. All we have to do is let's just get the highest word in the topic. Let's just do that. I don't know if that's this. Let's look at the docs. Oh, it's in decreasing size? No, it's in semantic similarity. So let's just use the first topic word that comes back from this. So let's actually store topic names equals topic 0 4x in topic words. Okay, so now we have the topic names, and then instead of this we'll do topic names using that ID. And then now we will actually store, instead of the topic ID, we'll store the topic name. And then, hold on. So we're saying if the score is greater, then use this with the new topic name. Then, oh, we gotta change this too. And understand that our topics are, it's not like a real topic right here. Social, I get. ODO, yeah, I don't know what websites I was. Oh, I know why it says ODO. It was a site that I was scraping. Okay, whatever. We have like 10 sites that we're using here. Okay, so eventually we need to do like 1,000 different sites. All right, so let's go and self doc map. So now this is going to be a map of, oh, we need to change this, of the ID, the eyes, the index of the document in our data set to the related topic name. And now let's, so this is not going to be the topic name. We want to save this in our data set that we're loading up here. So all we got to do now, finally, because this is an array of objects, we're going to do this. Then we can say topic. That's all we got to do. And we can say this topic equals that. And then we got to save it. And let me, so let's save JSON to Python. I've searched this, I always forget. Well, we could just do this. Let's do, what should we call this file? Topic data set, and then right plus is f dot right, or is it, no, there's a JSON function for this. There's like a JSON.save, right? I already went to this. Yeah, JSON.dump, and then you pass in the file object. Nice. Well, I already have it loaded. So JSON.dump, and then F, and the documents. All right. So let's see if our data is good. And actually, I'm going to update our clean dataset thing. I'm just going to, just so we can test to see if we actually ran everything well. To name the topics, it might be useful using, yeah, LLM to summarize the topics. That's a good idea. I should do that next video. To a single word, since an array of words is what defines a topic. That's a good idea. Do you think I could not use an LLM? You think there's any way to not do that? That's a good idea. And that would be easy if I just like I could just use the Hugging Face inference API. Yeah. Is there a way to do that? Is there a way to just get the word that summarizes those words in like a pretty efficient way? Does that mean, do you know what I mean? You can look at the scores. What do you mean? You mean like looking at the variance between the scores? Because I'm already getting the top ranked one. I mean like how do I get the word that's most like the word that's the mean of those words? Oh, is that what you mean by getting the use the distribution and lower the dimensionality? Okay, that makes sense. Okay. I should just use an LLM though, but that actually that sounds like a good idea. Alright, so let me load up this JSON file with our new data set. And oh, my bad. That's not what I want to do. Read file sync. Well, let's run this in the meantime. And let's run topic gen save, and then we want to say we're saving the topic with this clean dataset file. So this is like our input dataset. All right, cool. Let's do saved dataset. Okay, so let's go and do this. In the meantime, let's just do this for our what did I call it? Topic dataset. This isn't a clean file. Let me just create a new file for this. This is just gonna be like a read. You can look at this, yeah, and use that coordinate. Nice. Yeah, that sounds like a good idea. Touch. No, I call it topic. I've heard touch so many times. Topic dataset.json. No. I want to say just read dataset. So I have it. My dataset is a lot. So the reason why I'm doing this is because I don't want to. And then this could be all this stuff could be a Python script. But I just want to read this without. I don't need to do this. But I want to read this. So without having to open up these like huge files, so I just want to overwrite this because the HTML here is like a megabyte per thing or like a couple of megabytes per thing. So let's do that for now, and so let's return. That's all we need to do. I just want to make sure this looks good. Okay, so. Okay, and we don't want to use this one. We want to use the one that we generated, which I don't see here. So I'm guessing we did something wrong and it broke. So let's see what broke. Yeah, something broke. Oh, it's the wrong function name. Okay, because I put it on self. Self this. Self that. I've got to hop off, but really dig this idea. Can't wait to see where you take it. Yeah, dude. Yeah, next time it's gonna be great. It's gonna be great. Here we're just gonna. It sucks. The topic stuff took so long. We may not get to the CSS to like actually. I'm gonna start it. I'm gonna start after we get this data set. I'm gonna start the script for actually, because the way I want to actually get the CSS framework set up is I want to find common sub arrays in our data set. I'll show you what I mean. Let's just get this running. Okay, we got a data set. Finally. Jesus. Okay. Let's. Oh, you know what? I stopped it early. I think I stopped it too early. Hold on a second. No, I don't think I stopped it early. Okay. But I don't see topic on this. Yeah, I don't see topic on this. Our script messed up. Hold on. So I don't see topic. So this, you know what? I'm getting the index of the map in the array and I'm mapping it to this. So pretty sure I have to do that. I may not have to do that though. Do I have to do this? I don't know. No, this would be a key error if that didn't work. Pretty sure. So why would this not work? Oh no, yeah, the keys, I did range 0 to 10 for it. So it gets 0 and then it sets this. Okay, so it gets the if1 and it maps it to topic name. Let's log this in the end. Now we're gonna keep going. We're gonna keep going. Never stopping. We'll stop, obviously, but I want to get started on the CSS framework. Because once we get this CSS framework done, we'll be able to do some really cool stuff to compress the data set. Okay, so it's 0. Yeah, so this worked. Nice. This part worked. 1 month special, 24-hour stream. Yeah, I should do it 24-hour stream. That'd be great. I'll do that. Well, one thing I want to do is I want to set up hackathons. I think that'd be great. Where we could all work on stuff and see who wins. See who gets the coolest thing. That's cool for me. So why? So let's read again. That's so weird. Why isn't there? I don't see the topic key. Let's see. So I say for each item in this, this definitely should have ran. Maybe this isn't doing what I think it's doing. Let's just log this. And then let's also log, whoops. So let's log this and let's see if this actually has, let's log the keys for this. Just to see if it's actually getting the keys. No, I want to have a hackathon stream where we can all build stuff. We'll see who gets it. Oh wait, I ran the wrong file. We'll see who wins. We'll have a prize pool. We'll all pull in our money and see who can have the coolest project. We'll have a vote. I think that would be great. 10x hacks. 10x hackathons. That'd be great. Let's see. So this is almost... Let's go. Let's go. This is the part where it's slow. When it creates the dense vectors from the sparse vectors. Have you messed around with any music generator? I haven't. I want to use... So Meta just came out with... Oh, my bad. Keys is undefined. Oh, it's dot keys, right? But Meta just came out with... I don't need to log this. With audio... what's it called? They came out with an audio model that's really cool. I'm gonna have a stream where I try to make some beats with that. I think that'd be really cool. But it would be even cooler. So what I really want to do is, because I've been messing around with Whisper a little bit, is getting text from audio on podcasts. And I have a little script where I have a question to answer data set from podcasts. So I can convert the podcast to the question and the answer back to back. And like a key, that's the question, like a map of the questions to the answers. Okay. Wait, what? Oh, yeah, okay. No, that's good. So that worked. But the problem is the data set's not saving properly. Let me just make sure my read dataset thing is reading the right file. Yeah, it's reading the right file. I'm saving it there too. Yeah, I'm saving it. Okay, so this isn't saving. See what happens after I do this. Yeah, AudioCraft. Yeah. AudioCraft is cool. I also like... Oh, it worked. Hold on a sec. Yeah, okay. It worked that time. I don't know why it didn't work the other time. Okay. So now I linked the topic to each of the... So now they're successfully clustered. It's stored in our data set. Let's quickly just start writing a script to look at our data set and analyze the style, everything in the style tag, and group it together. I'm going to use Cheerio to do that. So Cheerio, if you don't know, is a very good NPM package for doing, it's pretty much if you had jQuery in JavaScript. It's pretty, in Node.js. So this is a good thing if you want to analyze websites without having to use crazy XPath. It's another reason why I like, because Node.js for web scraping. Because let's do this. So we're going to do this, and we're going to have a jQuery selector object that we're going to be able to use. Okay, so let's go. So we have a little script to do our topic stuff. We have a script to get our data set with our web crawler. And now let's make a script to generate CSS framework. And this is going to be from, to generate a CSS framework from our data set. And we're going to get Cheerio. I'm telling you, if you want to be an efficient web scraper, use Cheerio. Or use Node.js. very worth your money. Python's good too. I mean, in general, I just mean do browser automation, and there's a lot of great browser automation tools in Node.js. Okay, so first we're gonna do the same thing we did before. We're gonna load the data set. So we're gonna load this data set here. We're gonna do read file sync, and we're gonna say we're gonna get the topic data set that we have. And the reason why is we're going to label our CSS classes with the, what's it called? We're going to label our CSS classes with the topics we just generated from our HTML data set. So that's where everything's, that's how everything's working here. So I just realized, it's like I'm looking at the stream, it's so far back. It's so funny how far back what I'm doing to the stream is, but that's okay. Alright, so what we have to do first is we have to get a style mapping. Well, we have to get an array of all the styles. So this is what you should do. This is our style array. This will just be an array of all of the styles on the page. So we'll just say for let. So on each thing in the data set, this is the routine that we want to do. So data set, item, data set. We want to say data set, item. We want to get the HTML. We're not doing anything with the metadata anymore. We don't care about that. We care about the HTML. We care about the topic. So let's do, let me think. Actually, yeah, this is what we want. So we want to we want to load this into Cheerio. Cheerio.load dataset item. And then we can do jQuery. Oh, we're bringing jQuery back, okay? So we're gonna get jQuery, and we're gonna want to start at the HTML at the body node. My bad. And this because it's our root node, and we're gonna want to style everything in here. So we're gonna have to do a recursive function to get every single. Oh, you know what? We should make a little function for this, but we want to recursively get the style for each. Actually, we don't have to do anything crazy, so well, we could do it recursively. It's fine, but let's just say, you know, get style embedding. You get style attribute. And we'll do it for this style array, and what we're passing this is the element, comma. Actually, yeah, we don't have to do this. We can just scope it outside here. But actually no, we don't even need to. Yeah. We want to do this, but we just keep concatenating. So we're gonna have a huge array with a ton of styles in it. Or we're gonna recursively, so this is a way, you don't typically want to do this, but we're gonna do it here. But we're gonna be passing, because I don't think this is a huge stack problem. Actually, this is a big stack problem. Never mind. I'm not going to do that. What I mean is I was going to pass the array into this function that we're accumulating, but recursively it's not a great idea. So let's just make it global. Let's just use this global reference, and then just make this this function utilize this global. You want to always be thinking about memory, so you're not getting the Stack Overflow. You want to use Stack Overflow to ask questions, right? Ding. Okay, so element dot attribute style dot split. I forgot what the data set looks like. I think we can just split based on this and then trim. My bad. We want to trim. We don't have to loop. We don't have to do a trim in the loop. Yeah, it's fine. It's fine. I forgot if it's a space after this. Yeah, it's fine. So we want to split this, and then we'll just push this to the style array. I forgot how this works. So we actually want. So the way we want to generate the CSS classes is we want it to be scoped per element. So we don't want it. We want to have an array of arrays. So a matrix of all of the element styles. And then we're gonna find common subclasses. So we're gonna find common classes within this. So I think we could just do this. And we're gonna have to get the children. Forgot how to do that. Let's do Cheerio, get children, get child elements. Let's see. All right. Find all. I think I need to just do find all. I just want to get direct children because I want to do this recursively. Do I care about this being recursive? Why can't I do get star? What would the drawbacks of that be? What am I doing? Why can't I just do get star and then loop through everything? Why wouldn't that work? I'm trying to think about why that wouldn't work. Why wouldn't that work, right? Why was I doing this recursively? Alright, so we don't want to just push this actually. We want to push an object that has the styles and it also has the name or the topic so that later on we can use that topic and that'll be this. Okay. So after this, let's log the style array. So really what we want to do is we want to find a ton of common subarrays in this array. Hold on. Let's log node generate CSS framework. We got an error. For each isn't a function. What? Oh, whoops. Okay. Okay, so okay. Let me think. So we're going to loop through all the elements. We don't want to run a callback. We just want to do style push. Let's do that. Nothing happened. Isn't that great? So why? So this isn't an iterable. Oh, whoops! I just opened up Chrome. Move through elements. Let's get rid of this child element thing. Oh, it's dot each. My bad. Okay, so let's do dot each. Nothing happened. Hmm? Is this asynchronous? I don't think it is. No, oh, nothing happened. Let's do body, everything. Let's do something? No. Let's log the HTML. See if it's even loading. Oh, it's not. It's not loading anything. That's what's going on. Why? Is this, yeah, this does have a ton of stuff in it. Metadata. Let's just close this. Pretty sure it's called HTML. Is it not called HTML? No, it's definitely called HTML. So why? So when I run this, it's not working. So it's actually not able to parse the HTML. Let's console log this so we can see what this looks like. Why do you pick YouTube to stream on? Oh, it's a data buffer. We have to do the same data buffer thing that we did in the beginning. So like, it's just the most convenient. I use it. I wanted to stream on Kick though. Let's see, where's this buffer thing? And like Rumble. Was it clean data set? Oh yeah, we had to do this like buffer thing. I mean, it's not a buffer thing. It's just literally getting the buffer or converting the buffer to a string. Okay, so website CSS framework. When we load this, we want to load the buffer data. Okay. Buffer is just a object in Node.js. Oh, element attribute is not a function. Do I have to do this old jQuery thing where you gotta convert it to that? That's so weird. Okay. Split is not a function on this. I thought this would be a string. Oh, it's undefined. Let's see. So it definitely shouldn't be undefined. Every single element here should have an attribute style. So let's just look at get attribute Cheerio. I thought it was just a direct jQuery thing. Yeah, it's ATTR. Definitely is. Style. Style. So let's just do if this is undefined, ignore it. Should definitely be defined. Unexpected type of selector. Wait, what? Okay, I see. So we don't want to do this. So let's go back to that loop through every element on Cheerio thing. the perfect results using Cheerio. Find. So they're doing a map here. Let's just do this. No, we don't want to do that. Oh, they just do the $sign this. Is that gonna work? It's an old jQuery thing. Unexpected type of selector. Man. Is it because I have to await? I feel like I definitely don't. Yeah. Maybe read mood tools instead. Maybe need mood tools instead. Oh my god. Let's see. We can. Oh, this is how they translate it to an array first, and then they get the element, and then they do that with the element. Interesting. Let's use our trusty array from. And let's actually do a for each. Let's get the element and see if this does it. If there's none of this, let's return. Okay. Jesus. All right, so we got our list of styles for everything. Oh, we got to trim it. Whatever. All right, let's trim it. So let's get each style.trim. Okay, so yeah, it's a little slower, but all right. So here's what we're gonna do. Each one of these things is a unique thing, and we want to be able to go through here and find common subarrays. We're going to do it in an unoptimized way first. So there's a combinatory function, a combinations function in Python that's really nice, in iter tools. I'll see if JavaScript has a similar one. All combinations of the array, and I want to get everything that's at least 3, and I want to sort them by their most frequent, and I want to get like the top 90% of things, and that'll be our CSS framework. Okay, so wait, what? It's definitely not the way to do it. Is this actually how to do it? Is this actually? Oh, I see. Okay, we don't want to do it like this, but we want to keep the array structure. So they reduce it, and then they keep returning the map of the array concatenated to the rest, to the other arrays. Okay. Of array. That makes sense. I want to say like subarray. I feel like that'll be a better thing for us to use if we say subarray. God, mood tools is so, it's like just hearing it just makes me. Oh, actually, we don't want to do this, but this is actually like that's a cool thing. But we want to use an array, so let's just do subarrays. Also, there's a way to do this with there's a trie that's meant for this, a suffix tree. So there's actually, we don't want to do it because it's overkill, and it's fine. We don't have to do it, but we can use, if you want to find common sub combinations of things, use a suffix tree, a generalized suffix tree. Just going to show some information about this. So like we have a data set where we need to essentially condense it and dedupe it a ton so we can figure out how to build up our own little, we want to essentially generate some, like, use the combinations. So in the concept of dynamic programming, you have this way of, you have greater functions that can be made up of little smaller optimal functions that still keep it into polynomial time, so it still makes it so this is a polynomial expression, there's a way to, when you're kind of and that's it, whenever you're doing anything recursively, you're actually just doing dynamic programming, kind of. I mean, you know, I'm sure someone would disagree with that, but that's the way I look at it. It's like there's a series of smaller optimal functions that come together to create the greater. It's like it's a divide and conquer way of doing it. So oh, they think I'm a bot because I search so much. That's how you know you're 10x. Just kidding. No one's really 10x. But yeah, but the suffix tree is just a way of, let's go back to that example though. A suffix tree is really cool because it's a way of kind of it's so small. Oh, it's big. Okay, cool. So the suffix tree is a way of breaking down using like a trie type format. If you don't know tries, it's a tree. It's sort of breaking down the characters of your string in a kind of like almost like a lookup search. Here you can use this by combining many strings together into this suffix tree, and then working your way back from the end of the string, you keep recursively generating where the last suffix of that last character you're on, the pathway to build that character, and you start from the end, and then you go work each character into the top, and in the end, this is one for like ABA, ABBA. There's a way to find a lot of common sub sort of, I guess, arrays within an array, like a lowest common array, subarray, or character. You can look at it as characters in a string and arrays and arrays. We're not doing this because we don't care about the order. So the reason why I'm not doing this is that I don't care about the order. I'm not trying to find like words in words, because styles themselves are unordered, right? I just want to find a ton of combinations that have a lot of similarities in them, and then which is going to be huge. I'm going to have to optimize it. For now, it's going to be unoptimized, but subset combos in array. So this is like a super simple algorithm to do this. Yeah. Let's. Oh, this. That's not it. Yeah, this is it. So let's look at this. So it creates a new array with the array length. It fills it, and then it maps each item with the greater array with a filter on each item where it's filtering. Oh, you know what? I actually don't want to do it like this. I want various orders. Yeah. Oh wait, no, this does do that. Is this actually gonna do it? Let me test this one. Combinations 2, 3. Oh, it does do it. Okay, I gotta get rid of that empty one in the beginning. So how does this work? Yeah, it's a lot of bitwise. The bitwise I'm guessing it's just, oh my god. Let's see how this is actually working. Oh my god. Right, that makes sense. So it's okay. 0, 1. Then what's he setting? J. J is the index in each filter. All right, cool. So let me try for 1. Oh wait, hold on. AI. This index. Wait, is J not what I think it is in here? This is. Oh, okay, I get it. Okay, so he's just finding. Okay, I think I get it. I'd have to like look at this more, really, but I'm just gonna copy and paste it. Okay. I think I understand. Don't fully understand. I'll have to research. Okay, so let's use this. I don't use bitwise operator for anything, so. All right, so let's go through after we get all the styles. So actually, we want to get the styles for each topic. I'm now realizing. No, we want to get a CSS. How does this work again? We want to get the CSS class for each generate comment CSS. I think we want to do a CSS framework for each file and then condense them. No, we want to do it for each topic. Yeah. Sorry, I know that sounded it's weird, but let me just, so I need to convert the data set to, first we actually have to do this, and we have to do this combinations magic on for each topic. So we have to get a topic mapping, yeah, it's fine. And then we want to say topic mapping, topic equals this, and we can also do a reduce, but that's fine. But alright, so we could do this, we could preload this, and then we could say if the topic is in topic mapping, do this, simple loading of the data set, or simple loading of a map. We're just splitting this array into the map, and then else we're just going to load it up. You'll see this a lot. You're just checking if the key's in it, and then you're going to load it up with that within the key. And then, so now we have a mapping of each topic with all the HTML data files in that data set. And now we're going to for each, so we actually want some, like a function to create like a ran string. And for this, let's just do the n, and then let's just do some characters, and these characters can be A-I-J-K-L-M-N-O-B-U-R. Look at me, I'm I'm a smart zoomer. HIJKLMNOP. I'm kind of like a millennial too. QRST. Now I know my. All right. So all just things that you can have a CSS class that can be in a CSS class. Let's just say, you know, for I equals 0, let I less than n, I plus plus, cars, then we want to have a new string, and then we want to return new string, and then we just want to get, so math random will give you something between 0 to 1, so we can multiply this by our cars length, and then we can do math floor because this is an array that has an index, and we get the math floor on this, and that's fine, right? And this is our random integer, and then we just get cars. I feel like I'm off by 1 for some reason. We get cars for that, and then we just do new string plus or equals that. Okay, so we're getting a random string, and I just want to do this so I can name the classes. The class is going to be a combination of the topic dash the random string. Let's just do 5 characters for now. This is how we'll name our classes for our semantic CSS class. And we're gonna do another thing to combine the classes in the end. So we have, well, let's just comment that out for now. But because we need to see if there's any similar classes across these topics that we can combine the two things together. So we have topic dash topic 2. Just in case there's some overlapping ones, we can just combine them and do some deduping. Okay, so rand string functionality. Is this missing it? No, we're good. Okay, so the crazy bitwise stuff I don't understand. But it works. I should have just looked at the one that was complicated that didn't use bitwise stuff, operator stuff. All right, so the data set is, so now we need to actually go in each topic mapping. So for topic so we're gonna have 2 files here per topic. So every topic is gonna have a CSS framework, and then we're going to combine them into one big one. And then we're going to convert our data set to use the framework. It is so elite. Bitwise is so elite, right? I can't be 10x because I don't use Bitwise. I don't even no, I've never had a reason to use that. All right, so combinations. Oh, you can also see my failed script at this. I failed at trying to do this a month ago. All right, so let's go, and it's not that I failed, I just had other stuff to do that wasn't my, I'm streaming now, so I can do my crazy obsessive coding and try to make money off of it. So that I can have an actual reason to do it. All right, so we want to go and, oh no, our style array here, we don't want to do this. We want to actually push. So we don't want to do this. Why am I doing this? We want to do this here. This doesn't matter. So we want to say if dataset item topic is in topic mapping. Then we'll do this. So we'll set this to a variable. We'll say style object. We don't need this, so we can just make it an array. So style array. So this will be an array of arrays. We could push that array and load it up with that array, and then okay. So now we have the topics pointing to we're so close. We have our clustered HTML topics pointed to our styles, and now we need to do this combinations function for every style. For let style array of style arrays, and then we want to run this combinations thing on the style array. This is going to take a while. This is not optimized at all, but we want to say let's see, combinations, combos, style combos. We want to get rid of, so we want to say if style combos. We just want to make sure it's like greater than 2. So this is combinations. Oh, I just realized it's gonna be like some of them are gonna be flipped. That's fine. Let me think. This is kind of gonna suck. Hold on. Combinations equals. That's actually no. This isn't gonna suck. It's fine. It's fine. Everything's fine. So we want to push this to an array, and then we want to count combo in. This is not optimized. I just want to get it done first before thinking about it. We want to compare the indexes. This sucks. Wait, hold on. We gotta get an occurrence map for each of them. We gotta map each to the amount of other combinations are in here. So we can't. So I'll just have to do do some sort of reduction on the indexes for each of them. This is very large. It's very unoptimized, but it's okay. So we can do this. We can say for style combo of, let me think. So we could say for style. So we need to have an occurrence map. So occurrence map. And this is going to be style combo pointed to the amount of occurrences there are. And then we can say, there we go, n square quadratic. I just realized I gotta skip the one that I'm in, but so the way I'll do that is I'll get the index, and I'll get the index here. This will be II, and then the way I would do this is if I is II, continue. I just want to make sure I'm not checking the same one, but either way, I just need to see whether all these combinations. I'm trying to find all the common sub lists within these lists, and the problem is I don't just need to do this. I need to do this. I need to loop through each style. Well, it's not a loop. I need to do style combo. Yeah, it's live. What's up? I need to do style combo 2, which is an array of the styles dot reduce b, and then I want to say return index of. I need to do return the greater one index of a let me think. Let me just remember the order they have here. Just gotta remember this order right here. A, B. Oh yeah, I forgot it. This just so it starts at 1, 2, and then it's always the next one and then the previous one before. So we'll say A and index of B is greater than. So we're just trying to match them. So this is just a way to match. Matched occurrence is occurrence. No, we're not. I'm not writing tests. I'm creating a CSS framework from trying to make a CSS framework from a ton of web pages that I crawled to try to like a semantic one. So I'm clustering all the HTML pages, and then I'm labeling using the topics I find in the clustering. I'm labeling the CSS classes with that cluster. So you can find it and. Oh, don't. This isn't typical. I don't typically combine. I'm just like trying to work fast. I would have different folders for each of these typically. Like I'd have a Python set up and then I'd have a Node set up. Like a Node folder for like the Node project if it is a mono repo. Let's see. I'm trying to do a Boolean. So I want to say if A is a Boolean and return. We just want to keep returning if B. So we're doing a reduce. We're trying to see if there's another combo that matches, even if it's not in the right order. So we're doing a reduce function here. So let's reduce this. If the index of this is greater than 1, that means it's an occurrence, and else if it isn't a Boolean, that's the first thing. We'll have to check if A and this. Okay, so because the way it works is A, as you keep going. Oh, actually, so if we do this, we need to do A and this. I think that's how that works. I think that's how that works. So like the way, so really what I'm testing here is I'm saying if I had X equals 1, 2, 3, and I had Y equals. So like Y equals 1, 2. Actually, you know, it's a better thing. Let's do const Y equals 1. 2. No, we can do this. We can do this. But and then Y equals 2, 3, 2, 1. I want to make sure these things are equal. And I would say y.reduce, change these to x. It's true. Okay, cool. Let's try it with something that isn't true. Oh, I just realized this isn't gonna work if I need to make sure all things are accounted for. So first I need to say these both have the same length. So actually I can just ignore it if the lengths are different. So if this dot length is not equal to style combo dot length, then continue. But else, if this reduce works, then it's an occurrence. And if it's an occurrence, meaning, so like what I'm doing is I'm trying to see if these arrays, if two arrays match, by just checking all the things in a reduce function, even if it's out of order. So if it's an occurrence, then load up the occurrence map with the style combo ++. So if style combo is not in the map yet, we're gonna have to load it up with 1. We're gonna have to say this is equal to 1. Okay, so all right. It's like maybe this is gonna work. Let's make this else if. Oh wait. I know these are both continue. I get it, but they're just two separate things, and I'm just keeping them two different things just to make it readable. All right. So let's log this huge occurrence map and see if this actually works. If this occurrence map works, then we have our CSS framework. We're very close. Very close if this works. Style arrays is not defined. It's such an old error. You ever test something after not testing for a while, and it's the oldest error ever? Okay, so we want to do this topic. Alright, so style combos. Oh, combinations is not a function. Did I not paste combinations? It's right there. Oh, style combinations. I thought everything was gonna work first try. Everything's just supposed to work first try. Everything has to. If everything doesn't work first try, you suck. Just kidding. Just kidding. Yeah, it's taking a while. Hold on. Let me just stop that. Yeah, it's gonna take a ton. This is not optimized. This is n squared. First, let's just log that we're getting CSS framework for topic. And when I say CSS framework, I just mean like a series of CSS classes. So we'll say getting occurrences. Dang, I forgot this might take like a long time. This might take like a long time. I didn't know I was gonna keep going. I didn't know I was just gonna keep going. That's okay. I thought I was gonna like stop. Like I'm just going. I'm just going right now. This is a good one. This is a good one. There's a lot of stuff that I've been really wanting to finish and like get done. And Matt came in and helped. I was like freaking out on why the top to vector thing didn't work, and I just didn't read it right. This is good. This is a lot for just like a few hours. I think we're at 4 hours. Wow. It's tomorrow I gotta move around. I gotta like get to the gym in the morning. Happy Sunday. And then this week I'm starting a new contract, which should be fun. I need to get some money from a business so we can push some ads. This should not be taking this long at all. Hold on a sec. Because it didn't do this log yet. Why would it be? Oh, this takes a long time. Wow. I didn't know this would take this long. I did not know this would take this long. There's no way that's the same page. Hold on. Wait, what? Is this the same thing? What? Oh my god. I got a heap error. Oh my god. I got a heap limit error. Wow. Haven't got that one in a while. Wow. When was the last time I got a JavaScript V8 engine heap error? What? So it's a heap error probably because JavaScript is not C, and this would all be stack operations here. This would all be stack memory. Alright, so did it pass this though? No. So it's this thing is a big deal. Okay, let me run it again. I didn't know this was gonna be a big deal. Let's actually log some stuff here. Entries. I just want to get an index here. Oh my god. What's the length of this? This is probably huge. This is huge. Okay. See how I can. Oh, it just stops it. Interesting. Yeah, it's slow. How do I speed this up? Let's log the length of each of these style arrays. Let's see how big these are. So if it's 50, it's like a lot if it's like 50. Let me think. I could so that what that means is there's 50 styles in it. So how do I make this faster or not use as much memory? Style combos, and then it pushes this to style combinations. Style combinations is in this. I can make these global variables maybe. Let me look at this error and see ineffective mark compact near heap limit. Jeez. I just assumed that I wasn't gonna break it. Why would I assume that? Yeah, I'm in memory leak. Alright. Yeah, I forgot. You can just pass. You can just increase this. Let's see if this just deals with it. Crack the neck. Okay, let's see. Well, that's not gonna work out. It's at 30 right now. So around 29, it just gets so slow. This isn't optimized. That's one problem. There's a better way of doing this. Style combinations. Maybe what I should do is I should build the occurrence map as I go, rather than getting all the combinations. Wait, I can't do that. No, I can do that. As I get the combinations, I check the occurrence map, and then I need to free memory after it. How does one free memory here? Well, there's one thing. Oh, wait a second. This is wrong. Yeah, this is wrong. It needs to concat the combos. And I don't want to check if the combinations is greater than 2. I want to go and I want to do for let combo of style combos. Another entries. 0 I could say if, let's see, if I'm just trying to, I can do a filter. Dot filter combo dot length. It has to be greater than 2, and is this getting unique combinations? Because let's see, let's look up combination of subarray. The thing is no, I know what you're saying, but I don't think I can set it to null though. I know what you're saying though. Only because it's this thing that's getting huge. I don't know if I could set it to null. Yeah, because it's just breaking while it's building this thing. Well, let's see if this fixed it. You're right though, yeah. Yeah. Oh, assignment to constant variable, my bad. There's okay, so that didn't do much. Well, it's doing it's doing a few less things. Let me see when did I test out this? Does it have any duplicates? No, it doesn't have any duplicates. Let me think. I wonder if this is block scoped. It's probably the filter. Let me use this one. This one has a function in here. The thing is this isn't I'm not getting a call stack issue. I'm getting a heap issue. See if this one's faster. What's the difference here? See, this is what I thought it was. I never saw the bitwise stuff. Ooh. Wait, how do I just do that? Okay. Alright, but okay, so combine, okay, and then what's the min? The min's 2. Oh, the min's, so this comes with a min. Cool. What's this doing? So, oh yeah, so this is how I thought it would be, is you recursively just slice the next thing, and then you say what you got, which is a concatenation of the current thing, and then you slice everything after, and then you just keep moving along. Makes sense. I wish it wasn't a function though, but I don't think the function is the issue. I don't think. I'm just gonna keep the vars. I don't think the function's an issue. And we don't have to do this. We can just do this because it comes with it. Yeah, I know my Mac is losing its mind here. Oh wow, this is this is so much worse. All right, we're so close. I may have to figure this part out offline and just run this on a better computer. That's crazy. Wait, that can't be real. It can't really have been that much worse. All right. Thanks for sticking along, Kevin. It's been fun. We did a lot. So close. Gonna have to just stream the rest of this next time. Alright. Learned a lot. Learned how top2vec works. Learned more about Word2vec. Learned that JavaScript has heap issues when you... I think I'm underestimating how much data I'm using. I'm definitely underestimating how much data I'm using. I need to just use some high-powered machine. Alright, see you, man. This was fun. Alright, so if you're still around, you might be a psycho. I don't know if I want you to subscribe if you're still around, honestly. Just kidding. No, but subscribe, join the Discord, donate, give me a new laptop, support the new laptop, donate links in the subscription. I'm like a YouTuber now. Smash that mother... I can't say it. I feel like YouTube's... Alright.